Yeah. Okay. Yes. Good evening, dear students. Welcome to the today's session. Yesterday, we have completed that construction of alternators. The salient pole and cylindrical rotor alternator construction we are completed. Okay. And main discussion yesterday, it is a damper winding. Damper winding, the function of the damper winding is to eliminate the hunting rotor oscillations. So hunting is the phenomena takes place only in synchronous machine, correct? Because synchronous machine has to rotate only at synchronous speed, no other speed. Always, no load, full load, overload. It has to be rotated only at synchronous speed, right? Yeah. So when rotor deviates from synchronous speed, it will tend to oscillate, right? Yeah. But induction generator can rotate any speed, right? Yeah. But synchronous generator has to rotate only at synchronous speed. Otherwise, rotor oscillations will come into picture. That is hunting. But we have seen what is the various effects of hunting and how hunting can be eliminated. So by using the damper winding, damper winding works on the principle of induction. When synchronous machine induction action will comes into picture, then the rotor rotate less than and more than synchronous speed. Okay. And also we are completed cylindrical rotor synchronous machine. Cylindrical rotor synchronous machine. The main key points are the winding. Field winding is distributed in the slots. Okay. Yeah. With the distribution, 2/3 of the state rotor periphery, the flux distribution can be maintained sinusoidal. In various slots. Right? Yeah. But it is made with the solid steel forging. By that, rotor is mechanically strong, can be driven at high speeds. So they are best suitable for steam power stations, steam and gas power stations. Okay. But only minimum number of poles, 2 poles are worst case 4 poles, and with that they will have smaller diameter, larger axial length. Okay. And no damper winding is required in cylindrical machine. No damper winding is required. And the solid steel rotor is itself act as a good damper bar. Solid steel rotor, eddy currents damping, eddy current damping. And also we started that armature winding. Armature winding is mainly, it can be divided into 2 groups. Concentrated, distributed, but again under distributed it is full pitch and short pitch, and even fractional start, integral start winding. But generally alternator, the armature winding is distributed winding, short pitch, and then it is fractional start winding. Yeah. And why to have that many modifications in the armature winding? Modifications, why to have distributed short pitch and fractional start winding? That is all they will be to eliminate the harmonics. And also we have seen what is the reasons for harmonic. Main reason for harmonics is saturation. Saturation is the main reason, because at the center of the pole, more flux densities, it will tend to saturate. So we will get in our all machines, in our alternator, it is a flat topped wave. Flat topped wave is a non-sinusoidal. It can be divided into sinusoidal functions by applying the Fourier analysis. Because for easy mathematical analysis purpose, instead of taking a flat topped wave total, we are dividing that into sinusoidal functions. So first one is called fundamental, except that all others are said to be harmonics. Okay. Yeah. But only odd harmonics will generate, no question of even harmonics. Even harmonics will not generate due to even symmetry. I think you might have seen the signals and system, that is the Fourier analysis. As long as positive half cycle, negative half cycle is same, there is no question of even harmonics. And even some students are asking, sir, how even harmonics are eliminated? Let me show that. So first I will start with, I will show that how even harmonics are eliminated, because that was the question at the time of IAS examination, Administrative Services examination. Let me show that, and after that we will continue the armature winding. Okay. So first let me explain why even harmonics do not exist. Why even harmonics do not exist. Do not exist. Only odd harmonics will generate. Even harmonics won't exist. Right? Yeah. Just a minute. Even harmonics will not exist. Let me show that. Why? Because see, flux density waveform. If you take flux density waveform, a non-sinusoidal waveform can be divided into sinusoidal functions. See, this is the fundamental. This is the fundamental component. And say second harmonics. Second harmonics will have two half cycles, no? Second harmonics will have two half cycles. Yeah. See, this is B1, this is B1, and this is B2. Second harmonic flux density waveform. The fundamental flux distribution, this is the fundamental, and this is second harmonic, say. Second harmonics. Second harmonics will have two half cycles, no? Frequency is double. Nth harmonic frequency is n times. So within one half cycle, there are two half cycles of second harmonics. Frequency is double. Yeah. If you take a conductor, let us take a conductor. I will take one conductor here, one conductor here. That is a coil. So this coil has kept. This coil has kept. See, this is one coil. Is a coil, right? And this coil will have two sides, no? Coil will have two sides. Coils will have two sides. This one side of the coil, dear students, see, one side of the coil is cutting the fundamental flux distribution, the north pole flux. Positive is north pole flux, right? Yeah. North pole flux, positive flux, north pole flux means E1 will be upwards direction. This is E1, induced EMF is E1. And the second side, other side, it is cutting the negative half cycle. South pole flux. Negative half cycle means it is dot, na? Dot. So again it is E1. This is cross and this is dot due to fundamental. Because one side of the coil, it is cutting the positive flux. Are you getting my point? So this side of the conductor is cutting positive flux, whereas this side of the coil cutting the negative flux. Negative flux means dot. Positive flux is cross, say north pole and south pole flux. Then what will happen? The net EMF is said to be E1 and E2. If load is connected, say what they will do? They will maintain the current. They will maintain the current in this I1. They will maintain the current, and their voltages are said to be aiding polarities. But whereas if you see second harmonics, this side of the coil it is cutting the positive flux, and this side is also cutting the positive flux. Second harmonic, positive flux. Both are it is cutting positive peaks. Now what will be the E2? E2 also cross, and this side of the coil also it is E2, that is also cross. So in the first coil, current is going like this, I2. Second coil, the current is going I2. Then what is the net current? Tell me. net I2 is equal to 0. Net I2 is equal to 0. Will it maintain any current? No, it won't maintain any current. The current will be 0. So therefore, no question of even harmonics. No question of even harmonics. With respect to fundamental, if you draw, with respect to fundamental, with a voltage source, this is fundamental. How fundamental? Minus and plus. Even this is plus minus, minus plus. One is cross, another one is dot. This is cross and this is dot, na? Yes. For example, one is 10 volts, another one is 10 volts. What is the net voltage across the coil? 20 volts. Due to fundamental. Due to fundamental. This is fundamental. With the fundamental. Fundamental. But whereas second harmonic, if you draw the same thing, say you may be thinking like that. Second harmonic flux is there. When second harmonic flux is there, it also will cut the flux. EMF is induced. Okay. One side of the conductor is cross, na? Now, other side of the conductor also cross. E2. This is E2. E2 and E2. Both are upwards direction only, na? Both are upwards. This also upwards, this also upwards. Fine. So for example, you take, this is some 2 volts, this is 2 volts. What is the net voltage? Net voltage will be 0. Net voltage is 0 across the coil. This is for second harmonic. For second harmonic. Okay? Yeah. Both are crosses, na? Yes, they will get cancelled. In other words, we can say the even harmonics are said to be, even harmonics will get cancelled in the coil. On two sides of the coil, even harmonics are said to be opposing polarity. But the fundamental, you see, this is even, even. Fundamentals, how they are? Aiding polarities. Fundamentals are aiding. But even harmonics are opposing polarities. So therefore, they will get cancelled. They will get cancelled. So therefore, statement is all on two sides of the coil, the even harmonics are said to be the even harmonics on two sides of the coil. On two sides of the coil will be in opposing polarities, not aiding, in opposing polarities. Opposing polarities. Therefore, they get cancelled. They get cancelled out. Cancel out in a coil. In a coil. Therefore, they do not exist. Therefore, the even harmonics do not exist. The even harmonics do not exist. Okay? Even harmonics will get cancelled. Fine? I have taken coil almost full pitched coil. Fundamental voltages are aiding because one side of the coil cutting north pole flux, another one is cutting the south pole flux. But whereas the even harmonics, both are cutting the positive peaks. Okay. Yeah. Fine. I hope this is clear. Now let us move to the next topic. Okay. Yeah. Fine. Okay. Right? Fine. Some of you still, I hope you are raising a doubt. Dear students, listen once again. Some of you are expressing a doubt. You are not understanding, you told some of you. See, I am taking a full pitched coil, Where I have kept this is from fundamental. If you take from here onwards, I have taken some 45 degrees, say 45 degrees. And from negative of cycle also, this is 45 degrees. Na? So almost coil span is full pitched coil I have taken almost. Even short pitched also it is going to be same. This side of the conductor, listen, this one conductor one, say for example, it is cutting the positive fundamental flux. Dear student, positive fundamental flux. And positive flux means EMF is cross. Okay. But this side of the coil, it is cutting the negative flux. It is dot. So EMFs, their currents are, fundamental currents are said to be aiding here. Okay, aiding here. If load is connected, they will drive the current. What is the meaning of that? Their voltages are aiding, even and even, 2E1 aiding. That can be represented cross and dot, na? Yes. Current is derived from positive. Here also current is derived from positive. So fundamentals are aiding, fundamental voltages. Not only fundamental, all odd harmonics are said to be aiding on two sides of the coil. But the even harmonics, you see, even harmonics, this conductor, it is cutting the positive flux, positive second harmonic flux. Other side also cutting the positive flux. So both are crosses. So both are crosses means what is the net current? Zero. The net current zero means what is the net voltage? Net voltage is also zero. Okay. Yeah. Fine. Now let us go to the next topic. That is, as I told, the armature winding, it can be distributed under that short pitch, under that fractional slot winding. First, I am going to take up the short pitch winding. Okay. But before coming to the short pitch winding also, let us see some terms related to armature winding. Terminology, terms related to armature winding. Terms related to armature winding. Terms related to armature winding. The importance of terminology is, here we are going to see terminology means what is a coil span, pole pitch, slot pitch, etc. terms. You may be knowing pitch factor Kp is equal to cos alpha by 2. If alpha is equal to 60 degrees, Kp is equal to cos 60 by 2, cos 30. Cos 30 is equal to root 3 by 2, 0.866. Don't expect such type of questions. Kp cos alpha by 2 means if alpha is directly given, no coaching is required. Right? But that alpha may be given in different terminology. If alpha is equal to 2 slots, say, what is the angle? Alpha is equal to 2 slots, what is the angle? If alpha is equal to, right, 1/3 of slots per pole, then what is alpha? Okay. If alpha is equal to, right, so 1/6 of the pole pitch or 1/6 of the pole pitch, ultimately you need to convert that into angle. Different examiner, for example, 5 examiners are there. Same question, they will use 5 terminologies. But you need to understand that whatever the questions are being given. Okay. So let us see first terms, and after that I will come to the short pitch winding. Terms related to armature winding. First one, coil and coil span. Coil and coil span. This is a coil. Is a coil. Of course, I am taking a single turn coil. Is a coil. And these are said to be active length of the coil. This one and this one is said to be active length of the coil. Active length of the coil. Active length of coil. And these are said to be end connections. These are end connections. End connections, they are also called overhang. They are also called overhang. End connections are overhang. But whereas this portion is said to be active length of conductors. This portion, these are said to be active length of the conductor. Why active length means this portion only will cut the flux. This portion only will cut the flux. What is the induced EMF in end connections? Will the end connections will cut any flux? No, it won't cut. No EMF is induced in this portion. EMF is induced only in this and in this portion. Active length of the coil. Active length. In other words, for example, if you see, this is the stator core, na? Yes. This is the stator core. To take, this is the stator core. In this is one slot. This is one slot, like one slot say. These are the slots. We will keep the winding in the slots. We'll keep the winding in the slots. This is one side of the coil, and this is other side of the coil. Other side of the coil. Say, this is a coil, one coil. One coil. Fine. Coil. So the portion of the coil sides which is existing under the slot, that only will cut the flux. Correct? Dear students, see, this is the conductor. What is the pole length? Pole length also same, na? Pole length also same. When pole is moving, it cuts only this portion. This side is there, na? The end connections. This is said to be end connections. They won't cut any flux. They won't cut any flux. That's the reason this portion only called active length of the coil. Active lengths. Active lengths of the coil. EMF is induced only that portion. Of course, here I have drawn the diagram horizontally, but you can keep vertical. What is going to happen? Vertical means now I am taking the coil as vertical. Vertical. Machine is kept like this. Machine is kept like this vertically. Okay. So this is the coil. One coil. This active length of the coil, but practically coil is never be a single turn coil. It is not a single turn coil. There will be multi-turn coil. Not only one turn, it will have multi-turn coil. Say this is the second coil. And this is 3-turn coil. 3-turn coil. And 4-turn coil. Like a coil can have many turns, multi-turn coils. Coils are multi-turn. More number of turns will be there in coil. Multi-turn coil. And this is said to be coil span. Next term is coil span. Coil span. That is also called coil pitch. Coil pitch or coil angle. Coil angle. That will be given with beta. I will show with beta. Coil angle. So coil span is the distance between two sides of the coil. This is the coil, na? Yes. Distance between these two. That is the coil span. So coil span is the distance between two sides of the coil. Coil span. That is a beta. Coil span is the distance between distance or angle, I can say. Distance or angle. Angle. Between two sides of the coil. Between two sides of the coil. Distance between two sides of the coil. That is said to be coil span or coil angle. Can also be called as coil pitch. Coil pitch. Now, how you can measure the coil span? How you can represent the coil span? Coil span can be given in terms of, coil span is a distance between two sides of the coil. Distance, and don't say it is not meters or kilometers. You have to say technically. Technically, the coil span can be represented in terms of slots you can represent, or in terms of electrical degrees. If you want, you can also represent in mechanical degrees, or in terms of slots per pole. Slots per pole. You can represent like anything. See, if coil span is equal to, pole pitch, if coil span is equal to pole pitch, or that is equal to 180 degrees electrical, or that is also equal to slots per pole, say slots per pole, S by P, then that is said to be full pitched coil. This is said to be full pitched coil. And if all the coils are full pitched coil, then it is said to be full pitch winding. All the coils are full pitched coil, full pitch winding. Coil span is equal to pole pitch. We are going to see what is the pole pitch. Coil span is equal to pole pitch, or 180 degrees slots per pole. That is the full pitch. And if coil span is less than pole pitch, or less than 180 degrees electrical, or less than slots per pole, S by P, then it is said to be short pitch coil, or fractional pitch coil. You can also call it as the fractional pitch coil, or it can also be called as corded coil, cording coil, you can say, or cording coil. Cording means short pitch. These terms you should know. Cording coil. If coil span is less than that, less than pole pitch or less than 180, is short pitched coil. Then winding is said to be short pitch winding. If all coils are short pitched coil, then it is said to be short pitch winding. Okay. Yeah. Short pitch winding, or fractional pitch winding, or corded winding. This is one term, coil and coil span. Coil span denoted with beta. Next term is, let us see pole pitch. What is the meaning of pole pitch? See, pole pitch or it can also be called as pole angle. Pole pitch or pole angle. Pole pitch or pole angle. Pole pitch is the angle for each pole. Pole pitch is nothing but angle for each pole. For example, if you take I am taking 4-pole machine. 4-pole machine say four-pole and 12-slot machines. Yeah. On that, let us take 12 slots. Slot machine I am taking. Stator slots. There are the stator slots. And here This is North Pole, South Pole, North Pole, South Pole. 4-pole machine. 4-pole machine, pole pitch is the angle for each pole, angle for each pole, angle for each pole. For example, see, this is the quadrature axis, no? Yes, this is the quadrature axis. This is a q axis, interpolar axis. This is also q axis. This is said to be pole pitch. Pole pitch means angle for each pole. It is said to be pole pitch. Pole pitch. But pole pitch is equal to how much? 180 degrees. Pole pitch is the angle for each pole. Pole pitch is the angle for each pole. Okay. Pole pitch is the angle for each pole. Angle for each pole. Angle for each pole means how much? If you take each pole can be generate 1/2 cycles, na? Each pole generate 1/2 cycle. Say this is North Pole, this is South Pole. Therefore, what is the angle by North Pole? 180 degrees electrical. This is also 180 degrees electrical. Pole pitch is equal to 180 degrees. Therefore, pole pitch is equal to how much angle? 180 degrees. Pole pitch always fixed. Pole pitch is equal to 180 degrees. It is fixed. That's the reason I have written here earlier. If coil span is equal to pole pitch, that is equal to 180 degrees. Okay, pole pitch is always 180 degrees. So here 4 poles are there, say. Here I have taken 4 poles. This is 1 pole pitch. And this is said to be 1 pole pitch. PP, let me call 180 degrees electrical. Is also 1 PP, 180 degrees electrical degrees. This is also 1 pole pitch, 180 degrees. Okay, yeah. Pole pitch. 4 poles are there, 4 pole pitches that exist. Pole pitch is nothing but angle for each pole. Earlier, coil pitch, coil angle. Pitch, technical meaning. Pitch means angle. So pole pitch is nothing but angle for each pole. Because each pole generates 1/2 cycle. So each pole will produce one flux density waveform. Positive half cycle, north pole, south pole, negative half cycle, say. So how much angle it will contribute? It contribute an angle of 180 degrees. 180 degrees. Okay. Pole pitch is the angle for each pole. Now, see, yeah, each pole generate 1/2 cycle. Each pole generate 1/2 cycle. Each pole generate 1/2 cycle means, therefore, each pole create an angle of 180 degrees. Na? Yes. Each pole create an angle of 180 degrees electrical. 180 degrees electrical. Then for a p pole machine, if you take, here I have taken 4 poles. 4 poles means how much angle? 4 into 180. 4 poles are there. 4 pole pitches are there, na? 4 pole pitches. This is 1 pole pitch, 180 degrees. This is another pole pitch, 180, 180, 180. 4 pole pitches. So each pole create an angle of 180 degrees. General case, let me take. For a p pole machine. For a p pole machine, it is p poles, not 4 poles. Let us take p poles. For p pole machine, total electrical angle. Electrical angle, theta electrical is equal to how much? P into 180. Electrical angle is equal to P into 180. But what is the mechanical angle? Tell me. Mechanical angle is always 360 degrees only. It is a circle. Mechanical angle is always 360 degrees only. It is a circle. But electrical angle is, as poles increases, electrical angle increases. 10 poles are there. 10 pole pitches. 10 into 180. P poles are there. P into 180. Now you can take the ratio between these two. Therefore, theta electrical by theta mechanical is equal to what? P into 180 divided by S. P into 180 divided by, P into 180 divided by 360. 360. That is equal to how much? That is equal to P by 2. P by 2. Therefore, theta electrical is equal to P by 2 into theta mechanical. Theta electrical is equal to P by 2 into theta mechanical. Of course, this is well-known equation. Maybe all of you are knowing. Electrical angle is equal to P by 2 mechanical angle. Which angle is more? Electrical is more. Except for two poles. For a two-pole machine, electrical, mechanical same. And electrical is equal to P by 2 into mechanical, P by 2 to mechanical. But except for two poles, more than two poles, right? Electrical angle is more. For four-pole machine, electrical angle 2 times of mechanical angle. Right? Electrical is more. Why I am come across this point? Of course, you may be knowing. At the same time, students will get confused after going to examination. They simply remember like this: 1 is equal to P by 2 other one. 1 is equal to P by 2 other one. But which is left side, which is right side is important. Electrical is equal to P by 2 mechanical. If you blindly remember, definitely you will do the blindly mistake. But you apply common sense, electrical is more. Because mechanical is always 360 degrees only fixed. But electrical, as poles increases, electrical angle increases. Okay. So like for 4-pole machine, if you check, theta electrical is equal to 2 times of mechanical. Electrical is more. Okay. Now next term. Yeah. Next term, slot pitch. Term is a slot pitch. Slot pitch or slot angle is also called slot pitch or slot angle. Slot pitch that I am going to show with gamma. Slot pitch or slot angle. Again, slot pitch or slot angle. Pitch is nothing but angle, no? Yes. So slot pitch is the angle for each slot. So gamma, slot pitch, gamma is the angle for each slot. Angle for each slot. Angle for each slot. So in earlier diagram, we have taken 12 slots. I have taken, yes. See, in this 12 slots I have taken how many? 1, 2, 3, 4, 5, 6, 12 slots are there around that. But total angle how much? Total angle 4 180s are there. 4 pole pitches. 180 plus 180 plus 180. Electrical angle 180 degrees. 180, 184, 180, 724 poles are there. And that all 720 degrees are equally shared by each slot. I can say total 720 degrees, total slots 12. So therefore, what is the angle for each slot? 720 divided by 12 slots. 60 degrees will come for each slot. Like let me show here. For 12 slots, how many slots are there? Total 12 slots are there. For total 12 slots, what is the angle there? 4 poles are there. 4 poles. 4 poles into 180 degrees. Each pole 180 degrees. Then what is the slot angle? For one slot, how much? For one slot, how much? That is equal to 4 into 180 divided by 12 is equal to 60 degrees. That is only gamma. Slot angle for earlier example, 60 degrees. It is nothing but total angle. Total angle P into 180. If P poles are there, P into 180 divided by S say. Total angle by total slots. For each slot, angle is equal to total angle by total slots. Yeah. So, but general case, let me take. General case for a P pole, S slot machine. For a P pole, S slot machine. For this, total S number of slots. If there are S slots are there. For S number of slots, total angle how much? P poles are there. P into 180. P poles and total angle P into 180. S slots. But one slot how much? For one slot, how much angle? That is equal to P into 180 divided by S. And that also I can write 180 divided by S by P also. Slots per pole also you can represent. 180 by S by P. That is nothing but gamma. This is the slot angle. Slot angle. Slot angle. Yeah, slot angle. And representation or significance of gamma. Let us see what is the significance of gamma. What it indicates. Significance of gamma. It represent the phase angle between, or else let me write here. Yeah. Significance of gamma. Significance of gamma. It represent the phase angle between induced EMF of any two adjacent slots. Angle between induced EMF of any two adjacent slots. Induced EMF between any two adjacent slots. Earlier, I have taken a diagram. Like in this diagram. There were 4 poles. So in this, 12 slots are there. Na? See, this is North Pole, South Pole, North Pole, South Pole. Total 12 slots. This is slot 1, slot 2, slot 3, 4. Like 12 slots are there. Yeah. In these 12 slots, induced EMF in each phase can be represented with one phasor. Induced EMF in this conductor is there, na? Say that is E1. Induced EMF is E1 in this conductor E1. Similarly, induced EMF in the second conductor is E2. In this it is E3, like E4. But that E1 to E2 angle is said to be E1 to E2. This is gamma. This is gamma. This is also equal to gamma. Angle between this is nothing but gamma. Gamma. Yeah, that is gamma. The gamma. This angle is gamma. This is also gamma. Angle is gamma. Okay. Angle between E1 and E2 is said to be gamma. E1, phase difference between E1 and E2. E2. That is equal to gamma. Are you getting? Yes, this is the gamma. Any two adjacent slots will have phase difference is equal to gamma. Okay. Why so? Why they are coming like that? Why? Because there is a space displacement is there. Space displacement. Then phase difference will comes into picture. Right? Do you remember earlier? Just a minute, listen. Just a minute earlier. If you keep R phase winding and Y phase winding 120 degrees, then what is the phase difference between R phase to Y phase? 120 you will get. 120 you will get. Like wherever you keep slot to slot, the maximum value of induced EMF in the first slot to maximum value of induced EMF in the second slot will have phase difference is equal to gamma. Gamma. If you keep 120 degrees means you will get phase difference 120, right? If you keep 60 degrees, say, but in this example, gamma 60. But E1 to E2, the phase angle between E1 to E2 gamma means 60 degrees in this example. E2 to E3 also gamma, E3 to E4 also gamma, right? For example, when rotor is rotating in counterclockwise direction, say counterclockwise direction, it is cutting first for first slot conductor E1. Next it is cutting E2, second slot conductor. But E1 to E2 maximum value E1 to E2 gamma, E2 to E3 also gamma, because it is not cutting all the coils simultaneously one after other. After cutting first slot conductor, 60 degrees later it is cutting the second slot. Okay. And though even this E1, E2, E3, E4 may be for same phase even. For example, E1, E2, E3, they belongs to R phase. Even though R phase coils also will have phase difference is equal to gamma. Why? Why? Because space displacement is there. Space displacement. That we are keeping slots in different slots. Different slots means different phase. Okay. So these terms are enough. These terms are enough to start with the short pitch winding. Next, we are going to start with short pitch winding. Okay. Short pitch winding. Short pitch winding. Yeah. Short pitch winding. Short pitch winding. To start with short pitch winding, for discussion, easy understanding purpose, I would like to take a simple example. Simple example. The example is consider a three-phase, 2-pole, 12-slot alternator. 12-slot alternator. Minimum poles I am taking. 3-phase, 2-pole, 12-slot alternator. For this, the first what I am going to do, we will discuss the short pitch winding, pitch factor, followed by the objective questions. I am going to take nearly more than 10 objective questions. Each one is different questions. For each model, I will cover one, so that we are going to, you can see any examination, every model are going to be covered. Okay. First, let us try to understand clearly and all conclusions. After that, I will come to the objective questions. So for that, I am taking a simple example, a 3-phase, 2-pole, 12-slot alternator. For this, what is the slots per pole? Slots per pole, that is S by P. Slots per pole, how many? 12 by 2, 6. Slots per pole is equal to 6. Slots per pole 6. And what is the slot angle? Slot angle, gamma. Gamma is equal to P into 180 by S. We have seen that relation, na? Yes. P into 180 by S. E is equal to 2 into 180 divided by 12. The slot angle. P into 180 by 12. This is equal to how much? 30 degrees. Gamma is equal to 30 degrees. Okay. So do you remember all this relation? Because I am going to change this page. But every time I cannot come back to here. Okay. Gamma how much? 30 degrees. How many slots? Total 12. Slots per pole? 6. Slot angle 30. So let me draw the diagram. Short pitch winding. For this example, short pitch winding. See, there are 12 slots. 12 slots. Slot 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 slots. Total 12 slots I am taking. See 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 slots. 12 slots. Among these 12 slots, 12 slots, now 6 slots belongs to North Pole, 6 slots belongs to North Pole, and another 6 belongs to South Pole. South Pole. Okay, this is North Pole, this is belongs to South Pole. South Pole. Okay. This diagram I am taking from front view. Machine is placed vertically. Okay. Right? What I am doing here, for example, see, this is your stator core. This is your stator core. I am keeping vertically. Alternator can be mounted vertically or horizontally. Hydropower station vertically, steam power station horizontally. It is having 12 slots, say, slot 1, slot 2, slot 3, slot 4, 5, 6, like this. So many slots are there. But each slot, how you can represent, this is the slot now? Yes, this is the slot. This is the slots. Slots. We will keep finding in that. We will keep finding in that. Okay. I will keep finding here and here like that. Now, if you cut that portion, simply what to do? Cut this portion. I want to cut this portion. Cut the portion and open. How you can find? Actually, it is circular shape now. You cut that portion and you can open. It will become 1 to 12. I'm cutting and again open. Actually, it is going to be circular shape. Circular shape. Okay. First and 12 slots are adjacent slots. They are adjacent slots. If you draw the circle, this diagram, this type of diagram, we cannot observe anything. We cannot see on 3D. So therefore, we are opening. Otherwise, it is circular shape. Okay. Under North Pole, 6 slots. South Pole also 6 slots. 6 slots. Can you tell me here? Dear students, can you tell me, always, do you think always this 6 slots, first 6 slots always belongs to only North Pole? Not like that. They keep on rotating. Poles are always rotating. Na? Poles are rotating, say. One particular instant, 6 slots for R phase, 6 for Y phase. This is circular shape. Pole is here. When pole is rotating, one instant, the 6 belongs to North Pole, another 6 belongs to South Pole. But after rotation, some angle, now 3, 4, 5, 6, 7 slot belongs to North Pole, say remaining 6 belongs to South Pole. So poles are keep on rotating. But any instant, 6 belongs to North Pole, 6 belongs to South Pole. So this is one such an instant I have taken. Yeah. Coming to distribute short pitch winding. See, if one side of the coil is kept in the first slot, one side of the coil is placed in the first slot, for full pitch winding, where other side must be placed? 180 degrees. 180 degrees apart. 180 degrees to first slot. From first slot to second slot, what is the angle? 30 degrees, slot angle. We remember earlier, in this, what is the gamma? 30 degrees. Gamma slot angle 30 degrees. So slot to slot angle is 30 degrees. So from here to here 30, 30 plus 30, 60, 90, 120, 150, 180. 127 is said to be 180 degrees. If one side of the coil is in the first slot, other side will be in the 7th slot. 1 to 7. 1 to 7 is equal to how many slots? 6 slots it is equal to. 30, 40, 60, 80, 100, 30, 60, 90, 120, 150, 180. So therefore, one side of the coil in the first slot, other side we will keep in the 7th slot. 7th slot. So this is said to be full pitch coil. This is said to be full pitch coil. Okay. Full pitch coil. This is said to be coil span. What is that? This is the coil span. Coil span. So coil span is equal to how much? 180 degrees. Coil span beta is equal to 180 degrees. For full pitch winding, beta 180 degrees. If all coils are full pitched coil, then winding is said to be full pitch winding. Winding is said to be full pitch. Yes, full pitched winding. But I will take one coil is enough. For discussion only, with one coil only we are going to discuss. It is valid for all the coils. And if coil here I have shown full pitched winding, but instead of keeping in the 7th slot, if you keep less than the 7th slot, less than like 6th slot, 5th slot, it is said to be short pitch. 1 to 7, it is full pitch. Instead of that, 6th slot, less than 6th, 5th, 4th, that is going to be short pitch winding, short pitch. If you keep more than 7th slot, it is said to be over pitch winding, long pitch winding, long pitch. But whatever advantage you get for short pitch winding, same advantage you will also get for over pitch also. Over pitch also. For example, winding is short pitch with one slot and winding over pitch with one slot, also you will get same advantage. But one disadvantage will be there. What is the disadvantage? More copper at end connection. This length is unnecessarily increased, 1 to 8 at large. Practically, over pitch winding is never be used. I am going to show that at the end. Over pitch, short pitch winding, pitch factors are same. Elimination of harmonics, everything is same. Only drawback is more copper is required. Winding is never be over pitch. It is short pitch or full pitch. So let me short pitch by one slot. I want to short pitch by one slot. See, this is one slot. winding is kept in the sixth slot. Keep in the sixth slot. This is the short pitched coil. Short pitched coil. This angle is called short pitch angle. This angle is called alpha. Alpha is called what? Short pitch angle. Short pitch angle. That alpha is equal to how much? One slot we are short pitch. One slot. One slot is equal to angle is 30 degrees. 30 degrees. So that is alpha is called short pitch angle. Short pitch angle or fractional pitch angle. Short pitch angle or fractional pitch angle. But in this alpha is equal to one slot we have taken, yes, 30 degrees. So once alpha is 30, now beta is the coil span has reduced. Coil span beta is less than 180. Less than 180. So what is the beta value? Beta 150 degrees. Beta is 150 degrees. Beta 150 degrees. As alpha increases, beta decreases. Remember that always alpha plus beta is equal to always 180 degrees. In this example, what is the alpha I have taken? Alpha is equal to one slot I have taken. One slot means how many? 30 degrees. 30 degrees. But beta is equal to 150 degrees. Beta is equal to 5 slots I can say. Beta 5 slots. 5 into 30 how much? 150 degrees. 150 degrees. Therefore remember that alpha plus beta is equal to always 180 degrees. Alpha plus beta always fixed 180 degrees. Alpha plus beta always 180 degrees. Okay, yeah, just have idea about this. 180 degrees. Okay. So once the short pitch remains, coil span reduces, definitely reduces. Now, some student raise a doubt. They will raise a doubt. What is the doubt? Doubt is, listen, dear students, listen. If one side of the coil is kept under the full pitched winding, one side of the coil is kept under the north pole, and other side is kept under the south pole. One is north pole, one is south pole for full pitch. So one is cutting north pole flux, another one is cutting south pole flux. Both EMFs are aiding. Both EMFs are aiding polarity. But once you short pitch by one slot, by short pitching one slot means one side of the coil is under the north pole, other side is also under the north pole. One side, other side also north pole. Of course, they are having phase difference. But they do not always existing under the same pole. For example, pole is rotating, say, or coil is rotating, pole rotating or coil rotating. Let me take here, if a pole is stationary, okay, it is short pitched, 1 and 6, right? But when coil is rotating, what happened? After some time, the first coil will come under the second slot, and the next side of the coil will come under the 7th slot. Like that, coil is rotating continuously. If you short pitched by one slot means only 30 degrees duration, they existing under the same pole. 30 degrees only, same pole. But remaining 150 degrees is there now. Coil is rotating. Next it will goes to the other. Then from there onwards, they will be additive. At 30 degrees short pitch means 30 degrees only opposing polarities. But remaining 150 degrees is there now, aiding polarities. But anyhow, once for full pitched winding, one north pole, one south pole, the total 180 degrees aiding polarities, arithmetic sum we are going to call. But when short pitched means 30 degrees, they are opposing polarities. That's the reason net EMF is going to be reduced. For short pitch winding, net EMF decreases. That we are going to call vector sum, reduces. Yeah, fine. So, okay. By taking this, if for your short pitch winding, say, this is E1, induced EMF is E1, induced EMF is E1, and in this induced EMF is E6. Here induced EMF is E7. But E1 is equal to E, E6 also equal to E, E7 also equal to E. EMF per conductor is same. EMF per coil is same. Coil is same. Fine? Yeah. So now, if you take for full pitch winding, how it will be? First, let me write for full pitch winding. For full pitch winding, what is the coil span? Coil span is for full pitch winding, coil span beta. Coil span beta is equal to how much? Beta is equal to 1 to 7. 1 to 7. 1 to 7 means how many slots? Tell me. 6 slots. 6 slots it is. 1 to 7, that is equal to 6 slots. Correct? 6 into 30, how much? 180 degrees. That is, angle is equal to, this is slots per pole, na? Yes, this is itself slots per pole. Slots per pole. And that is also equal to 6 into 30. How much angle? 180 degrees. That is equal to pole pitch. That is nothing but full pitch. Full pitch. So for full pitched coil means, as I have given, if a coil span is equal to 180 degrees, or that is equal to slots per pole, or that is equal to pole pitch. All are matching, na? Yes. Yeah, coil span is equal to pole pitch. So 1 to 7 is equal to how many slots? 6 slots. Correct? Why? Because from here to here, this is one slot distance, 1 slot, 2 slots, 3 slots, 4, 5, 6. This is 1 slot. Next 2 slots, 3, 4, 5, 6. 6 slots only, then only 6 into 30, 180 degrees. Okay. But whereas for short pitch, how much angle? For short pitch, you see, for short pitch winding, what is the coil span? Coil span is equal to beta is equal to 1 to 6. I have taken 1 to 6. 1 to 6 means how many slots? 5 slots. 5 slots. But 5 slots is equal to how much? 5 into, okay. 5 slots means 5 into 30, 150 degrees it is. Beta is equal to 150 degrees. And what is alpha? Alpha is equal to 1 slot. 1 slot means it is 30 degrees. 30 degrees for short pitch winding. Okay. Now, let us find the induced EMF. For full pitch winding. For example, for full pitch winding, if your coils are connected, for full pitch winding, if you measure the voltage across this with a voltmeter, say, if you connect a voltmeter across this is a voltmeter I am connecting, voltmeter. So what is the voltage you will get across this? The voltmeter, say. Or if you connect a voltmeter for short pitch winding, that is the resultant voltage. That measures resultant voltage. Voltmeter measures resultant voltage. Let us say how much. First, I will take the short pitch winding. Short pitch winding it is, a full pitch winding it is 1 to 7. For full pitch winding, coil span beta is equal to 1 to 7. 1 to 7 means 6 slots. It is 6 slots. 6 slots means that is S by P, and 6 into 30 is equal to 180 degrees. That is equal to pole pitch. That is equal to full pitch. Now, if you take E1 here, if this is E1, induced EMF in the first slot, E1. Then what is the phase angle between E1 to E7? E1 to E7, that is beta. Beta is equal to how much? 180 degrees here. Beta 180. E1 and E7. Na? E1 and E7. One side of the coil is the first slot, other side is the seventh slot. 180 degrees. So, if you measure voltage across this voltmeter with voltmeter, that measures ER. If you measure with a voltmeter E1 and E7, E1 and E7, what is the resultant voltage? Potential difference. That voltmeter measures E1 minus E7. E1 minus E7. Okay. Resultant voltage. Then ER is equal to how much? E1 minus E7. E1 minus E7. But E1 is equal to E at an angle 0. E7 is equal to E at an angle how much? 180 degrees. 180 degrees. That is equal to, can I say, E minus of minus E. E minus of minus E. That is equal to E plus E. It is equal to 2E. ER is equal to 2E. 2 times of rated, 2 times of the voltage, 2E. That is arithmetic sum. Arithmetic sum. ER, E1 minus E7. Even instead of that, see, E1 and E7, two sides of the coil, two sides of the coil. Of course, E1 cross, E2 cross, E1 cross, E2 dot, na? But two voltages are aiding polarities. E1 and E7, both are said to be aiding. The induced EMF on two sides of the coils are said to be aiding polarities. So instead of taking E1 like this, even I can also, E7 is there, na? E7 can be taken on this side also. E7 can be taken on this side also. This is E7. E7 is also equal to E. E1 also equal to E. Then what is the resultant voltage? You can say directly you can add both. That ER also equal to E plus E. That is 2E. E plus E. That is 2E. 2E. ER is equal to E plus E. That is equal to 2E. That is itself arithmetic sum. Can I say it is arithmetic sum? Arithmetic sum. Arithmetic sum. I am taking minus of minus. Dear student, E7 actually 180 degrees this side. This is E1, E7. But in a coil, with respect to coil, both are aiding. That's the reason I can say E7 minus of minus plus. You can also take this side, minus of minus plus. Now you can add directly. E1 minus E7, that is also equal to E plus E. E1 plus E7 also same. In the coil, arithmetic sum. But for short pitch winding, what will happen? See, for example, for short pitch winding, coil span beta is equal to 126. We kept 126. 126 means how many slots? 5 slots. 126 means 5 slots. 5 slots, that is equal to how much? 5 into 30 is equal to 150 degrees. 150 degrees. Then alpha is equal to how much? 1 slot. That is equal to 30 degrees. Alpha, one slot has short pitch. Don't think alpha not necessary, only 1 slot. You can short pitch, 2 slots are there. Say alpha can be 2 slots also. If alpha is 2 slots, what is the alpha? 60 degrees. Alpha, don't think alpha is equal to always 30 degrees. Some students are raising a doubt. Sir, alpha is equal to gamma na. Because in this example, gamma 30 degrees, therefore alpha also 30 degrees. Not like that. I have taken 1 slot, that's the reason alpha is equal to 30. If you take 2 slots, instead of keeping in 6th, if you keep in the 5th slot, so 2 slots are short pitch. 2 slots means then alpha is going to be 60 degrees. Alpha is going to be 60 degrees. More slots, short pitch, more alpha. Okay. With this, see, E1, this is E1, E1 to E6, na? Yes. Resultant voltage. Here, if you connect a voltmeter here, this resultant voltage, how much that we are finding? With voltmeter, I can measure between the two ends of the coil. So that is E1. Of course, what is this? This is E7. E7. But I need to find what is that E6. E6. This is E1. E1 is equal to E. But this is E7. E7. Whereas we are keeping in E6. E6 will have some phase angle. Yes, this is E6. 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 Okay, of course, E6 also equal to E. What is this angle? It is short pitched by alpha. It is short pitched by alpha. Earlier alpha, full pitch winding alpha 0, na? Yes, alpha 0. Short pitched by alpha. This is called what? Beta. This is the beta. Beta. Beta is equal to how much? 180 minus alpha. Because alpha plus beta 180. For this, if you want to find the EMF, what is the resultant voltage? Tell me. Resultant voltage. Okay. Resultant voltage ER is equal to, see, ER. ER is equal to E1 minus E6. E1 minus E6. E1 at an angle 0. Okay. E1 at an angle 0. But E6 is equal to how much? E at an angle 180 minus alpha. 180 minus alpha. Okay. That is equal to E minus 180 minus alpha means what? E at an angle alpha minus alpha. E at an angle 180. Or you see, what is the phase difference between this? E0, E180 degrees. Then if you want to find the magnitude of this voltage, how much? E square plus E square minus 2E. Minus 2E square into cos of the angle 180 minus alpha. 180 minus alpha. Correct? Yes. A vector and B vector. So this is the two phasors say. The resultant is equal to difference of both. I'm finding. I'm taking E1 minus is potential difference. Voltage is nothing but what? Potential difference. E1 minus E6. That is the voltage. If you connect a voltmeter, it measures the potential difference between this and this. Two phasors. That is E square plus E square. Difference of two phasors. Can I write for this? That is equal to E square plus E square minus 2E square. Cos 180 minus alpha is nothing but minus cos alpha. Minus cos alpha. That is equal to what? 2E square plus 2E square into cos alpha. That is equal to, can we write it as 2E square into 1 plus cos alpha? 1 plus cos alpha. That again we can write 2E square into 1 plus cos alpha is equal to 2 cos square alpha by 2 minus 1. That total is equal to square root of 4E square cos square alpha by 2. That is equal to 2E into cos alpha by 2. Therefore, ER is equal to 2E cos alpha by 2. Net EMF 2E cos alpha by 2. Or I am taking the voltmeter. And if you want to take, I am taking potential difference, na? Yes. But I want to take vector sum, arithmetic sum. Two coils EMFs are aiding polarities, aiding. Potential difference is nothing but aiding. Instead of that, I can also take like this. You take E6 minus E6. Just like here, E1 we have taken reverse, na? Yes. You want, you can also take this is also as E6. This is E6. Then this is also alpha, correct? Is alpha. Now what is the net EMF? Net EMF is vector sum of these two. Vector sum of these two. That is equal to how much? This is ER. This is ER. That ER also equal to 2E cos alpha by 2. 2E cos alpha by 2. Okay. 2E cos alpha by 2. By 2. This is called vector sum. Vector sum. There's a vector sum. Right? Yeah. Even if E and E6 is there, this is also E. E6 also equal to E, of course. Now, if this is A vector and B vector, can I write directly by vector sum? And E1 minus E6. E1 minus E6. That also relation will be same, na? That also relation will be same. Okay. From this relation, yeah. See, E1 vector sum, E square plus E1 square and E square plus E square plus 2E cos alpha. 2E cos alpha. What is that value? This is also equal to 2E cos alpha by 2. 2E cos alpha by 2. If you do that is also with that relation also, you will get the same thing. Same thing. Okay. Right? Correct? What is the Sirisha? You are raising your doubt. Tell me what is your doubt? Hello? Sirisha, what is your doubt? Hello?
Good evening, sir.
Good evening, ma. What is your doubt?
Sir, I didn't get here why we did vector sum and in full pitch coil arithmetic sum. I didn't get it, sir.
Arithmetic sum is 180 degrees. Na? I am taking this 180 degrees. Resultant is nothing but potential difference.
Okay.
Potential voltage is nothing but potential difference. E1 minus E7, that is net potential. That becomes 2E. Na?
Yes,
For
sir.
example, one coil 10 volts to 10 volts, total 20. 20 means can I call it is arithmetic sum or not? Yes,
Yes, sir.
arithmetic. But in the second case, that is also 10 volts to 10 volts. Total is, can you get 20 volts? No, not 20. Because it will be cos alpha is also coming. Na?
Yes, sir.
If alpha 0, it will be arithmetic sum. But when alpha is coming, it is vector sum. Two vectors I am adding. E1,
Okay.
yeah. What I am taking is here only, yeah, dear students, see, what I want to take is minus of minus, E7 is there now with respect to coil, minus of minus I am taking. Otherwise, you don't worry, you don't take that. Simply ER is equal to E1 minus E7, write it. This is 2E. But can I say it is arithmetic sum? Yes, 10 plus 10, 20 volts. Similarly, here also I have taken 2E cos alpha by 2, that is vector sum. Only thing is E6 is there now. Minus E6 I am taking plus E6 this side. E7 minus I am taking E7. Okay. Yeah. So that is a vector sum. Vector sum. Fine. right. Now, but when winding is short pitched, winding is full pitched, say, when winding is, okay, when winding is full short pitched, net EMF is reduced. It is ER. Full pitched winding EMF is more. Full pitched winding ER plus E, 2E, 10 plus 10, 20 volts, arithmetic sum. But vector sum always less than the arithmetic sum. Vector sum is always less than the arithmetic sum. And when winding is short pitched, net EMF will reduce. Net EMF will reduce compared with full pitch. But how much EMF is reduced? How much EMF is reduced for short pitch winding? That is given by a factor is called pitch factor. So pitch factor is, it is a ratio of induced EMF for short pitch winding to induced EMF for full pitch winding. It is a ratio of induced EMF for short pitch to induced EMF for full pitch. So now let me define that pitch factor. Pitch factor. So pitch factor is equal to, pitch factor, it can also be called as coil span factor, or cording factor, okay. Pitch factor, coil span factor, or cording factor. Terms are important. That I am taking with KP. Pitch factor, coil span factor, cording factor, that is KP. Therefore, that KP is equal to pitch factor. It is a ratio of induced EMF. The induced EMF per coil when the winding is sharp pitched. When the winding is sharp pitched by the induced EMF per coil, the induced EMF per coil, when winding is full pitched. When winding is full pitched. Okay. So the induced EMF per coil when winding is short pitched by induced EMF per coil when winding is full pitched. Or that is also equal to, can I write induced EMF for short pitched means it is the vector sum of induced EMF, per coil. One coil is taken, fine. The vector sum of induced EMF per coil divided by the arithmetic sum of induced EMF. Arithmetic sum of induced EMF. Induced EMF per coil. But what is vector sum? Vector sum is 2E cos alpha by 2 divided by arithmetic sum is 2E. That is equal to cos alpha by 2. Therefore, pitch factor Kp is equal to cos alpha by 2. Pitch factor Kp is equal to cos alpha by 2. But for nth harmonic, if you take nth harmonic, Kpn is equal to cos n alpha by 2. This is for fundamental pitch factor. Okay. This is for fundamental pitch factor. This is for nth harmonic. Nth harmonic pitch factor. Kpn, nth harmonic pitch factor is equal to cos n alpha by 2. Why? Because alpha multiplied with n. Yesterday I have shown angles for nth harmonic is equal to n times. Do you remember? Nth harmonic frequency n times of fundamental frequency. Nth harmonic poles also n times of fundamental poles. Nth harmonic angle is equal to n times of fundamental angles. Where angle is there, multiply. Therefore, from this, therefore, n alpha is equal to, for nth harmonic, n alpha. For nth harmonic, it will become n alpha. Okay. Kp cos alpha by 2. Nth harmonic, where alpha is there, multiply n. And the values of Kp. If alpha is equal to 0, what is Kp? Tell me. If alpha is equal to 0, what is Kp? 1. When you will get alpha 0? For full pitch winding. For full pitch winding, coil span is 180. For full pitch winding, coil span 180 means then alpha 0. Beta is itself 180, alpha 0. When alpha 0 means it is full pitch. But when alpha 0, what is alpha 0? What is Kp? 1. Okay. But when winding is short pitched, Kp less than 1. Therefore, Kp value will be less than or equal to 1. Kp value will be less than or equal to 1. Kp will be less than or equal to 1. Kp is equal to 1 for short full pitch winding. Kp is equal to 1 for full pitch winding. For full pitch. Kp is 1 for full pitch winding. But Kp less than 1 for short pitch winding. Kp is less than 1 for short pitch winding. Less than for short pitch winding. For full pitch winding, Kp1 is equal to Kp3 is equal to, all they are 1 only. Let me write this separately outside. The space problem, all this. I am trying to get all this information in a single page, but it becomes clumsy. Okay, I will write in the next page. See, Kp value will be Kp less than or equal to 1. Less than or equal to 1. Kp is equal to 1 for full pitch winding. Kp is equal to 1 for full pitch winding. For full pitch winding, Kp1 is equal to, Kp3 is equal to, Kp5 is equal to dash dash dash. Kpn. All they are equal to 1. All they are equal to 1. Which factors for full pitch winding same? Why? Why? Because alpha is equal to 0 and beta is equal to 150 degrees. 180 degrees. When alpha 0, beta is equal to 180 degrees. And when alpha 0 means everything will be 1 only, na? Yes. Kpn also, cos alpha by 2 is equal to 1. But for short pitch winding, Kp less than 1. For short pitch winding, Kp less than 1. Kp less than 1. Kp1 also less than 1. Kp3 also less than 1. Kp5 also less than 1. All they are less than 1 only. All they are less than 1. But general case, Kp1 is always greater than the Kp3 and Kp5 in generally. Fundamental pitch factor is more. Kp1 is more compared with Kp3. Okay. Now coming to, as I told, the main target of the short pitch winding is to eliminate the harmonics. Whether it may be short pitched or distributed winding, mainly to eliminate the harmonics elimination. Let us see what is the alpha to eliminate harmonics. How harmonics can be eliminated. Let me explain this. Mathematically, we know E is equal to how much? 4.44 Kp Kd phi ft. EMF equation 4.44 Kp Kd phi ft. And En, nth harmonic EMF. Nth harmonic is equal to 4.44 Kpn, Kdn, phi n, Fen and T. Kpn, Kdn, phi n and T for nth harmonic. But I want to eliminate nth harmonic. I want to eliminate harmonics means, see, if Kpn is equal to 0, then En is equal to 0. So that eliminated. It is said to be eliminated. Nth harmonic will be eliminated. Okay? Kpn 0, En 0. But Kpn is depends upon what? Kpn is depends on the alpha. Kpn is equal to cos alpha by 2. Therefore, what we will do is simply equate Kpn is equal to cos n alpha by 2 equal to 0. Equal to 0. Then En also equal to 0, na? Yes, En also equal to 0. From this, that also equal to cos 90, I can say. Cos n alpha by 2 is equal to cos 90. Therefore, what is n alpha by 2? N alpha by 2 is equal to 90 degrees. Therefore, alpha is equal to 180 by n. Alpha is equal to 180 by n. This is the short pitch winding, short pitch angle to eliminate nth harmonic. Short pitch angle to eliminate. Short pitch angle to eliminate nth harmonic. Short pitch angle to eliminate nth harmonic. This is alpha. Alpha. Okay. Once that is alpha, then what will be the beta? See, coil span. Coil span beta is equal to 180 minus alpha. Because alpha plus beta 180, na? Yes. Beta is equal to 180 minus alpha. That is equal to 180 minus alpha 180 by n. 180 by n. That is equal to how much? 180 into 1 minus 1 by n is equal to 180 into n minus 1 by n. Therefore, beta is equal to 180 into n minus 1 by n. This is the coil span to eliminate the nth harmonic. Coil span to eliminate the nth harmonic. Coil span beta to eliminate nth harmonic. To eliminate nth harmonic. Okay. For example, this on this you can expect simple questions now. Alpha to eliminate fifth harmonic. What is alpha? 180 by 5. What is a beta? Like that. Okay. Yeah. So to eliminate nth harmonic, alpha 180 by n, beta is equal to 180 into n minus 1 by n. But which harmonics you would like to eliminate? Tell me. Which harmonics we want to eliminate mainly? The fundamental harmonic is there. Third harmonic, fifth harmonic, seventh harmonic, ninth harmonic. Next page. The harmonics are fundamental, third harmonic, fifth harmonic, seventh harmonic, ninth harmonic, 11th, 13, 15, 17, 19, 21, 23, 25. Okay. Samosa also. You want a samosa? Vedi vedi samosa. Okay. 1, 3, 5. These are the odd harmonics, na? Yes. 1, 3, 5, 7 odd harmonics. But among this is the fundamental, na? First, this is the fundamental I want. Fundamental I want. And these are the odd harmonics, na? Higher order harmonics. Yesterday I have given all these things. Higher order harmonics. Lower order. And these are the higher order. These are the lower order is more dominant. Lower order is more dominant. More dominant. Okay. This is higher order, less dominant. Higher order, these are the less dominant. Their magnitude is less dominant. Higher order, more dominant. No question of even harmonics, only odd harmonics. That to be the harmonics. Yesterday I have given conclusions. I don't know how many of you remember or not. We can eliminate third harmonic, 9th harmonic, 15th harmonic, 21 harmonics, triplen harmonics. The triplen harmonics will generate only in the phases. That is 3 into 1, 3. 3 into 3, 9. 3 into 5, 15. Okay, 3 into 7, 21. Dash, dash, dash. These are called what? Triplen harmonics. Triplen harmonics. Cophasial harmonics or cophasial harmonics. Cophasial harmonics. Harmonics. But they eliminate in the lines. All triplen harmonics will be eliminated in the lines for star connection. Therefore, nothing to worry about third harmonics. Nothing to worry about third harmonics. Okay? Yeah. All triplen harmonics. All triplen harmonics. Triplen harmonics will be eliminated. Will be eliminated in the lines, in the line voltages. In the line voltages. Phases they generate, though they exist in the phases, though they exist in phases, though they exist in phases. But generally, voltage can be, loads are connected across the lines, na? Third harmonic will not exist. Yesterday I have shown third harmonics will be eliminated in the line voltages because they are cophasial, na? Cophasial. Therefore, which harmonics you would like to eliminate? Tell me now. We want to eliminate the 5th and 7th harmonics, mainly dominant harmonics. By using the short pitch winding, our focus is mainly on 5th and 7th harmonics. Of course, other harmonics also get reduced, but mainly 5th, 7th harmonics. Okay? Yeah. And to eliminate any nth harmonic, just now we have seen the coil span. The coil span to eliminate nth harmonic. The coil span to eliminate nth harmonic, alpha is equal to 180 by n, but beta is equal to 180 minus alpha, that is equal to 180 into n minus 1 by n. 180 to n minus 1 by n. Now, mainly we will focus to eliminate 5th, 7th. Third itself eliminate. Third harmonics is itself eliminate. No problem. Mainly dominant harmonic 5th, 7th. Therefore, the coil span to eliminate 5th harmonic. 5th harmonic alpha. Sorry, it is not coil span. No. To eliminate nth harmonic, na? I'm sorry. Reframe. Let me reframe. Alpha. Not, I am writing coil span. No? See, to eliminate nth harmonic. To eliminate nth harmonic. Alpha, short pitch angle alpha is equal to 180 by n. and beta is equal to 180 minus alpha. That is 180 into n minus 1 by n. N minus 1 by n. But mainly we would like to eliminate fifth harmonic. Fifth harmonic. So for fifth harmonic, what is alpha? 180 by 5. 180 by 5 means 36 degrees. Alpha 36 degrees. Alpha 36, but what is beta? Beta 180 minus 36. That is equal to 144 degrees. Chiral span is 144 degrees. Similarly, to eliminate seventh harmonic, alpha 180 by 5. 180 by 5 means it is 27.5 degrees. 27.4. 27.4 degrees. What is a beta? Beta is equal to 180 minus 27.4. That is equal to 153.6 degrees. Beta. From this, your observation is, if you go for alpha 36 degrees, say fifth harmonic 100% eliminated. Alpha 36 means fifth 100% eliminated, but not 7. Seventh is having its own alpha. Alpha is different for fifth harmonic, alpha is different for seventh harmonic. Okay? Yes. Alpha 36 degrees, fifth 100% eliminated, but not 7. And if alpha 27.4, okay, is it 27 point or 25.4? I think it may be how much angle? 20. Yeah. Right. How much it is? I correct. 25.4, I think. 25.4. Okay. Perfect. 25.4. And this is equal to how much? 154.6. Right, 154.6. Okay. Correct? Calculate one of you and tell me if that value is correct. 25 point. Okay. You calculate it. Right. Yeah. 154.6. Now, if alpha 36 degrees, fifth harmonic 100% eliminated, fifth 100% eliminated, but not 7. To eliminate 7th, 25.4. But we are interested to eliminate both harmonics. It is confirmed that the two harmonic, 5th, 7th, 100% elimination is not possible. Only one harmonics 100% you can eliminate, but not both. Okay. And I would like to eliminate both maximum percentage. Maximum means what to do? Take average of both. So by taking average, to eliminate both 5th and 7th harmonics, to eliminate both. To eliminate both 5th and 7th harmonics. 7th harmonics. Alpha is equal to 36 degrees. Alpha is equal to 36 degrees. 36 plus 25 point for both two. Nearly 30 degrees it is. Nearly 30. Okay. Nearly 30. 25.7. Huh? How much angle that is? 25.7. This is 25.7. Therefore, it is equal to 154.3. 154.3. Okay. 154.3, roughly 154.3. So this is 25.7, roughly 30 degrees. Actually, it is nearly equal to 31. I'm taking 30. Then what is Kiel span? Beta is equal to 150 degrees. Beta 150. Therefore, the 30 and 40, 150 degrees is more famous. Kiel span 30 degrees and 150 degrees is more famous. With 30 degrees of short pitch angle, nearly 80%, 75% of fifth and seventh harmonics will be eliminated. If you take alpha 30 degrees, nearly 75% of fifth and seventh harmonics both will be eliminated. Let me write that conclusion. Yeah. With Kiel span, most of the AC machine very famous. Alpha 30 and very famous. It's not only for alternator, all AC machines alpha 30. All windings are short pitched. Alpha 30 is the best choice because 75% of fifth cell, maximum percentage they will eliminate. In most of the AC machines, the conclusion is, in most of the AC machine, the Kiel span is chosen as, 150 degrees, or the winding is short pitched by, that is, the meaning is same, that is, winding is short pitched by 30 degrees. Winding is short pitched by 30 degrees. So that nearly 75% of both fifth and seventh harmonics, will be eliminated. Both fifth and seventh harmonics will be eliminated. Both will be eliminated. 75% means great reduction, large reduction of value. Okay, much reduction. That's the reason 30 degrees. Kiel span is 150 degrees is famous. 150 and alpha 30 degrees. Best one. Okay. Yes. And range of Kiel span. Range of Kiel span is 120 degrees to 150 degrees. 120 to 150 degrees, or that is 2/3 to 5/6 of pole pitch. 2/3 to 5/6 of pole pitch. 5/6 of pole pitch. 2/3 to 5/6 of pole pitch. 2/3 of pole pitch means how much? 2/3 into 180, that is 120. 5/6 of pole pitch, 5/6 into 180, that is 150. Pole pitch is equal to 180, na? Yes. So that is the range of Kiel span, 120 to 150 degrees. But most of the machines, 150 is best. 150 is best. Some machines it may be less than 150 also, but up to 120. It will vary 120 to 150. 120 to 150. Why so? Why Kiel span is only 120 to 150? Still, why not you reduce? The alpha I have given 30, na? Why 30? Still you reduce 30, 40, 60, all 90 degrees, more than 90. What is going to happen? If too much of reduction in Kiel span, if you reduce Kiel span too much, then fundamental EMF is going to be reduced. Fundamental EMF is itself reduce. For example, see here, Observations. See, alpha is equal to 0. What is beta? Beta is equal to 180 degrees. That is said to be full pitch winding. Full pitch. For this full pitch, calculate what is Kp1. Kp1 is equal to Kp3 is equal to Kp5 is equal to dash dash dash. All they are equal to 1. All they are equal to 1. All they are equal to 1 means 100% of fundamental exist. Because E proportional to Kp. E proportional to Kp. Right? Therefore, 100% of fundamental exist. Also, 100% of all harmonics exist. All harmonics exist. For full pitch winding, if you do for full pitch winding, what is happening? All harmonics 100% exist. Fundamental also 100% exist. But if you go for short pitch winding, alpha 30 degrees, say alpha 30, beta how much? 150. That's the short pitch winding. If you go for short pitch winding. So for that short pitch winding, calculate what is Kp1. Kp1 is equal to cos alpha by 2. That is cos 30 by 2. Cos 15. Cos 15 is equal to 0.965. 0.965. Therefore, 96.5% of fundamental exist. What does it means? Therefore, 96.5% of fundamental exist. Whereas, calculate Kp5 how much? Kp5 is equal to cos phi alpha by 2. That is cos phi into 30 by 2. How much? It is cos 75. Cos 75 is equal to 0.25. Cos phi alpha by 2. Cos 75, 0.25. I mean to say 25% of fifth exist. How much reduced? 75% of fifth harmonic is eliminated. 75% eliminated, na? That is a great reduction. Even seventh harmonic also same. Seventh harmonic also 75% eliminated. That is the point I have given. So with short pitch winding, nearly 75% of fifth and seventh harmonics will be eliminated. That is a great advantage. But fundamental, how much reduced? 96.5% exist. How much reduced? 3.5% is reduced. Reduced is very less, 3.5%. But how much? Almost all exist. Seventh harmonics, great reduction in seventh harmonics. Small reduction in fundamental, but great reduction in fifth, seventh harmonics. Okay. Likewise, if you take alpha, too much reduction, alpha 30. If you take alpha 60, what is going to be happen? Alpha 60 ante Kp cos 60 by 2. Okay. Cos 30. Cos 30 is equal to 0.866. 86.6% exists fundamental. Brother, alpha is equal to 90, say. It's over. Just I want to show alpha is equal to some 90, say for example. If alpha is equal to 90, beta also 90, short pitch. What is Kp1? Kp1 is equal to cos alpha by 2, cos 90 by 2, cos 45. Cos 45 means is equal to 0.707. Therefore, 70.7% of fundamental exist. Fundamental exist. But how much reduced? Nearly 30% is reduced. 30% of fundamental is reduced. This cannot be accepted. This cannot be accepted. Because magnitude of fundamental also important. Magnitude of fundamental is also important. Magnitude of fundamental also important. That's the reason too much reduction of coil span will reduce the, therefore too much reduction of coil span. Reduction of coil span reduces the fundamental. Therefore, beta 150 or alpha 30 is best choice. That is the best choice. Because small reduction in fundamental, but great reduction in fifth and seventh harmonics. Great reduction in fifth and seventh harmonics. Okay? Yeah, fine. So this is about theory. We have completed total. Now after the break, we are going to see the objective questions only. We will see the objective questions based on this pitch factor. I will give for each model one question. After having all this idea, questions will be you will feel very simple. So now take break for 20 minutes. Okay. And then we will start with the objective questions. Once objective questions completed, if time is there, we will start with distributed winding. So take break. Break for 20 minutes. Class will start. Okay. 7:37 means 7:57. Okay. Yeah. Right. Yeah. Fine. Now let us see the objective questions on this. Objective questions. The objective questions. For each model, one question I would like to give. Okay. So which covers all varieties of questions from all various examinations. Okay. See, number one, first one. The coil span. The coil span to eliminate. The coil span to eliminate seventh harmonic. Seventh harmonic is coil span to eliminate seventh harmonic is A bit. 1/7 into pole pitch, B bit. 6/7 into pole pitch, C bit. 7/6 into pole pitch, D bit. D bit. 7 into pole pitch. The coil span to eliminate seventh harmonic. Coil span to eliminate seventh harmonic. Okay. So what is the answer? Answer is coil span to eliminate seventh harmonic means we know that alpha is equal to how much? That beta. Coil span means beta. Coil span beta. Beta is equal to 180 into n minus 1 by n. N minus 1 by n. That is equal to 180 into seventh harmonic na 7 minus 1 by 7. That is equal to 6/7 into 180. 6/7 into 180 can also be written as 6/7 into pole pitch, or 6/7 into slots per pole, or 6/7 into full pitch. All meanings are same. All meanings are same. 4 examiners, they are preparing the same question, say. 4 examiners are preparing same questions. 4 varieties of options they can give. 4 varieties of options. So what is your answer? 6/7 into pole pitch. Correct? 6/7 into pole pitch, 6/7 into slots per pole. Slots per pole is always equal to 180. 6/7 into pole pitch. All meanings are same. Okay, only terminology you should know. Next question, see. Next question. The cording angle. The cording angle to eliminate fifth harmonic. Cording angle to eliminate fifth harmonic is A bit. 1/5 into slots per pole, B bit. 4/5 into slots per pole, C bit. 5/4 into slots per pole, and D bit. 5/6 into slots per pole. 5/6 into slots per pole. This is the cording angle to eliminate. Cording angle to eliminate the fifth harmonic. So the cording angle. Is it alpha or beta you need to calculate? Alpha. Cording angle means what? Alpha. So alpha. Alpha is equal to how much? Alpha is equal to 180 by n. Yes. Alpha is equal to 180 by n. That is 180. 180 by n means 1 by n into 180. Correct? 1 by n into 180. How much it is? 1/5 into 180. That is also equal to 1 by 5 into pole pitch also correct. Or 1 by 5 into slots per pole also correct. Or 1 by 5 into full pitch. All these are correct. Options can be anything. All they are correct only. You can use any terms. But here he has given how? He is giving only like a 1 by 5 into slots per pole. This is given. But all they are correct only. All they are correct. Everything is correct. Okay. Next. Coming to the next question, see. This one question. The coil span of an alternator. The coil span of an alternator is 160 degrees. Coil span of an alternator is 160 degrees. And which of the following harmonic? Which of the following harmonic is absent? Which of the following harmonic is absent? A bit, third, B bit, fifth, C bit, seventh, D bit, ninth. Is also one examination question. The coil span of an alternator is 160 degrees. Which of the following harmonic is absent? Absent means eliminated. If coil span is 160, which harmonic is eliminated? Yes. See the solution. Beta, coil span is given, na beta. Beta is equal to how much? 160 given. Then what is alpha? 180 minus beta. That is 180 minus 160 is equal to 20 degrees. Alpha 20 degrees. But alpha is equal to 180 by n. Which harmonic is eliminated means 180 by n. That is given 20 degrees. Then what is n? N is equal to ninth harmonic. Ninth harmonic. So ninth harmonic will be eliminated. This is your answer. Ninth harmonic will be eliminated. Ninth harmonic is eliminated. Okay. Yes. And similarly, one of the examination question, the coil span is 2/3 of pole pitch. 2/3 of pole pitch. Which harmonic is eliminated? Which harmonic is eliminated? A bit third, B bit fifth, C bit seventh, D bit ninth. Okay. Coil span is 2/3 of pole pitch. Which harmonic is eliminated? It is ninth, na? Yes, ninth. Beta given. Beta is equal to how much? Beta is equal to 2 by 2/3 of pole pitch. Can I say it is 2 by 3 into pole pitch means 180? Yes. That is also we can write 3 minus 1 by 3 into 180. Therefore, which harmonic is eliminated? N is equal to 3. So third eliminated. Third harmonic is eliminated. Third harmonic is eliminated. Okay, 2/3. 2/3 means 3 minus 1 by 3. 3 eliminated. Third harmonic is eliminated. Okay. Next, This is one type of questions based on the relation alpha 180 by n beta 180 into n minus 1 by 1 based on that relation. Now let me give another type of questions. Another type of questions. See, the question is a 3-phase 6-pole 90 slot alternator. 90 slot alternator. 3-phase 6-pole 90 slot alternator. Under that, first question. If the coil span is 1 to 13, coil span is 1 to 13, then the coil span factor is A bit 0.5, B bit 0.707, C bit 0.866, D bit 0.951. Now, next question. If the coil span is equal to 10 slots, 10 slot pitches, then the pitch factor is A bit 0.5, B bit 0.707, C bit 0.866, D bit 0.866, D bit 0.965. Third question. If the winding is corded by 2 slots. Winding is corded by 2 slots. Then the fifth harmonic cording factor is A bit 0.5, B bit 0.707, C bit 0.866, D bit 0.965. Similarly, fourth question. If the winding is short pitched by 10 degrees mechanical, then the third harmonic pitch factor is A bit 0.5, B bit 0.866, C bit 0.707, B bit 0.707, C bit 0.866, T bit 0.965. The winding is short pitched by 10 degrees mechanical. Similarly, have taken this? Okay, next question. Taken up to here? Okay. Next question is, Fifth one. Fifth one. If the coil span is equal to, right? Coil span is equal to, sorry. Coil span is equal to 11/12 of pole pitch. 11/12 of pole pitch. Then the pitch factor. Then the pitch factor is dash. Pitch factor is dash. Next. If the coil span is equal to pole pitch, say, coil span is equal to pole pitch, then the seventh harmonic pitch factor is, then the seventh harmonic pitch factor is, seventh harmonic pitch factor is, pitch factor is, check here. Then the seventh harmonic pitch factor is A bit, 0.5, B bit, 0.707, 0.707, C bit, 1, D bit, 1.5, 1.5. This is one type of questions, direct substitutions. Now tell me the answers for this. Okay. Right. Now, I hope you have taken now. Yes. See, question is a three-phase, 6-pole, 90-slot alternator. In that coil span is given 1 to 13. 1 to 13 means how many slots? You tell me. 12 slots. 1 to 13 means 12 slots. 12 slots. What is the angle? You need to calculate. Ultimately, Kp is equal to cos alpha by 2. So you need to calculate alpha in electrical degrees. 1 to 13 means 12 slots. 12 slots, what is its angle? 12 into slot angle. So this type of questions you need to calculate first slot angle. So let us see. You have taken this now? It's over. Okay. Now coming to the solution. The question is given a 3-phase, 2-pole. How many? 6-pole, sorry. 6-pole. A 3-phase, 6-pole, 90-slot alternator. 90-slot alternator. Okay. For that, what is slot angle? First calculate slot angle. Gamma. Gamma is equal to P into 180 by S. P into 180 by S. P is equal to 6 into 180 by 90. How much? 12 degrees. Gamma is equal to 12 degrees. Now first question. Come to the first question. Coil span, how much? Coil span beta given. Beta is equal to 1 to 13. 1 to 13 means it is equal to 12 slots. 1 to 13 means 12 slots. How much angle? 12 into 12, that is equal to 144 degrees. It is 144 degrees. Then what is alpha? Alpha is equal to 180 minus, once you know the beta, alpha is equal to how much? 180 minus beta. That is 180 minus 144. 180 minus 144. How much it is? 36 degrees. Alpha 36. Then alpha 36 means what is Kp? Kp is equal to cos alpha by 2. That is cos 36 by 2. Cos 18. Cos 18 is equal to 0.951. 0.951. Will be 0.951. Okay. Similarly, second question. Second question. Coil span is equal to 10 slot pitches. 10 slot pitches means 10 slot angles. 10 into 12 degrees is equal to how much? 120 degrees. Okay, that is beta. Beta is 120 degrees means then what is alpha? Alpha is equal to 60. Alpha 60 means what is Kp? Kp is equal to cos alpha by 2. That is cos 60 by 2 is equal to cos 30. Cos 30 means root 3 by 2. That is equal to 0.866. So Kp 0.866. 0.866. Is there any units for Kp? 0.866. Is it any units? No units. It is a EMF by EMF, na? Yes. No units for it. Is a simply ratio. Kp is simply ratio. Now third question. See, third question is given. Alpha is equal to 2 slots. Short pitched by 2 slots. Alpha is equal to 2 slots. 2 slots means alpha is equal to 2 into slot angle 12. How much alpha? 24 degrees. 24 degrees. And he is asking Kp5, fifth harmonic Harding factor. Kp5 means cos phi alpha by 2. That is equal to cos phi into 24 by 2. Cos 60. Cos 60 means 0.5. 0.5. Kp5 is 0.5. Alpha is given 2 slots. Now fourth question. Question number 4. Is it taken? Yes. Question number 4. Alpha mechanical is given. How much? Alpha mechanical 10 degrees. 10 degrees. But what is alpha electrical now? Alpha electrical is equal to P by 2 into alpha mechanical. Alpha mechanical. So that is 6 by 2 into alpha mechanical 10 degrees. How much it is? 30 degrees. 30. This 30 you have to substitute. In place of alpha, not mechanical degrees. Everything will be electrical degrees. Electrical degrees. 30 degrees electrical. Then Kp3 is asking, third harmonic pitch factor is how much? Kp3 cos 3 alpha by 2. So cos 3 into 30 by 2. That is equal to how much? Cos 45. Cos 45 is equal to 1 by root 2. That is equal to 0.707 would be your answer. 0.707. Fourth one. Okay. Next, fifth question. Fifth. Fifth question, coil span is equal to, coil span beta is equal to how much? Beta is equal to 11 by 12th of pole pitch. That is equal to 11 by 12 into 180 degrees. 11 by 12, 180 degrees. Okay. Then alpha you calculate. This is beta. Then alpha is equal to how much? 180 minus beta. Then Kp calculate. Kp is equal to cos alpha by 2. Okay. 11 by 2. Fine? Yes. That you can do it. The calculator is there, na? Yes. Kp is equal to that much. Similarly, say sixth question. Sixth question. Coil span is equal to pole pitch. Coil span is equal to pole pitch. Pole pitch means it is equal to how much? 180 degrees. 180 degrees. Therefore, it is a full pitch winding. Full pitch winding. Alpha is equal to 0 degrees. Alpha 0 na? Yes. Because beta is equal to, since beta is equal to 180. 180. Then what is Kp7? Kp7 is equal to cos 7 alpha by 2. That is equal to cos 7 into 0 by 2. Cos 0 is equal to 1. 1. 1. This is one type of questions. Okay. Or in this is giving options in terms of data is given in terms of slots, no? Slots. Only thing is, if any question is given this type, simply calculate the slot angle, they're over. Gamma calculated, say, how many slots it is short pitch. Okay. Now, let us see next type of questions. Yeah. Okay. Over na? Okay. Now next type of questions. Yeah. Next question is, see. Now I want to give the two gate questions. Earlier questions are not gate questions. Gate question is like this. A three-phase alternator with the slots per pole per phase. Slots per pole per phase is equal to 5. Slots per pole per phase is equal to 5. The coil span beta is equal to 12 slot pitches. 12 slot pitches. Coil span is equal to 12 slot pitches. Then the coil span factor is A bit 0.5, B bit 0.866, C bit 0.951, D bit 1.05. 1.05. Okay. Yes. A three-phase alternator with slots per pole per phase is equal to 5. The coil span is equal to 12 slot pitches. Right? Yes. The solution is, in this, coil span is given, 12 slots is given. Slots, 12 slots. 12 slots means how much angle? What is its angle? You need to calculate. Okay. See? Slots per pole per phase is equal to 5 given. 5 given. Then what is slots per pole? Slots per pole is equal to 5 into 3, 15. Because it is three-phase machine. Three-phase. If it is a two-phase, say I am going to write 5 into 2. 5 into 2, 10. Three-phase he has given 5 into 3, 15. That is three-phase machine. Slots per pole, S by P. Now slot angle is equal to, gamma is equal to P into 180 by S, or that is equal to 180 divided by S by P. 180 S by P. That is 180 divided by S by P, how much? 15. 15. That is itself S by P, no? Yes. Slots per pole means S by P. So it is equal to 12 degrees. Slots per pole means 12 degrees. Gamma is equal to 12 degrees. Yeah. That is 12 degrees means coil span beta is equal to 12 slots is given. 12 slot pitches. 12 slot pitches means 12 into 12 is equal to 144 degrees. 144 degrees. Okay. Then what is alpha? Therefore, alpha is equal to 180 minus beta. That is equal to 180 minus 144, 36 degrees. Then Kp is equal to what? Cos alpha by 2. That is cos 36 by 2. Fundamental only you have to calculate pitch factor. Unless otherwise mentioned, you need to calculate the fundamental. So that is cos 36 by 2 means cos 18. Cos 18 is equal to 0.951. That is your answer. Okay, this one. 0.951. 0.951. Wow. 0.951. Okay. Now, see, next question. Next one. The coil span, an alternator with pole pitch. Pole pitch is equal to an alternator with pole pitch. No, an alternator with coil span is equal to an alternator with pole pitch is equal to (18 slots. Pole pitch is equal to 18 slots. An alternator with pole pitch is equal to 18 slots. The winding is short pitched by. Winding is short pitched by 60 degrees. Short pitched by 60 degrees. Then the Then the coil span is A bit, 6 slots, B bit, 12 slots, C bit, 15 slots, D bit, 18 slots. 18 slots. An alternator with pole pitch is equal to 18 slots. An alternator with pole pitch is equal to 18 slots. The winding is short pitched by 60 degrees. Then the coil span is right. What is the answer? Yeah, what is your answer? Answer is C. B or C? Some of you are saying B and C. See, here, yeah, solution. An alternator with pole pitch is equal to 18 slots. Now, pole pitch. Pole pitch is equal to 18 slots is given. But what is the pole pitch is equal to 180 degrees? Pole pitch is equal to 180 degrees. So 18 slots 180 means there is what is slot angle? Slot angle gamma is equal to 180 degrees are there for 18 slots 180. Therefore, for one slot, how much? 10 degrees. 10 degrees. Slot angle is 10 degrees. And winding is short pitched. Alpha given 60 degrees now. Short pitched by 60 degrees. Alpha 60. Alpha 60 that is equal to 6 slots. 6 slots. But beta how much? Beta is equal to 120. That is a 12 slots. 12 slots. So he's asking about what? Beta is asking. Beta. Okay. Therefore, your answer is 12 slots. Coil span is asking. Coil span. Alpha 60 means beta 120, na? Because alpha plus beta is equal to 180. 180 degrees. Okay. In this only thing is options he is giving in terms of slots. Options are given in terms of slots. This is one type of questions. Okay. Next, I will give the different question. Different question. Okay. You're taken here now? Yes. These questions are quite simple and at the same time quite important also. In GATE examination, EMF equation problems are very important. Problems on EMF equation. But EMF equation is equal to 4.44 Kp Kd phi ft. So Kp calculation must be pakka. If anything is going wrong with Kp, your whole answer is going to be wrong, na? Yes. Therefore, you should be perfect about calculation of pitch factor. If you are perfect about all the terms, whatever we have used, if all terms, so you are having idea, digestion of all the terms, question you can easily understand. Is given alpha given, beta given, or in terms of slots given, whatever it may be given, simply you are converting that into your required value, alpha to be calculated. Okay. Yeah, now let me give the question. This is the important question. See, question is a three-phase alternator four-pole alternator, three-phase four-pole alternator with double layer winding, 3-phase alternator, 4-pole alternator with double layer winding. With double layer winding. Double layer winding has double layer winding has 48 armature coils. 48 armature coils. 48 armature coils. The winding is short pitched by the winding is short pitched by 2 slots. Short pitched by 4 slots. 4 slots. Okay. Then the pitch factor is. Then the pitch factor is A bit, 0.5 B bit, 0.866 C bit, 0.707 B bit is 0.707 C bit, 0.866 D bit, 0.965. Yes. So all of you try to do this problem. Everyone has to try. Let it be whether wrong or right. While you are doing, some idea you will get. Let it be it is wrong, no problem. But after doing some problems, you will go in correct way. A 3-phase 4-pole alternator with a double layer winding has 48 armature coils. Winding is short pitched by 4 slots. Okay. See, 48 armature coils are given. What is the question? Is given 48 armature coils. 3-phase 4-pole alternator with double layer winding. Winding is short pitched by 4 slots. Alpha is given 4 slots. Alpha is given 4 slots. Huh? Alpha 4 slots is equal to 4 into gamma. Gamma you calculate. But gamma is equal to what? Gamma is equal to P into 180 by S. P into 180 by S. But whereas slots are not given. It's not given. Not given. Then how can you calculate the gamma? Once gamma, if you calculate, problem becomes very, very simple. Right? Once you know the gamma, problem is routine. How to calculate gamma? Slots are not given. But instead of that, coils are given. Dear students, armature coils are given. That data you have to utilize. See, important thing is in double layer winding, number of coils is equal to number of slots. That information is required. Number of coils equal to number of slots. First, let me write. In double layer winding, this question is also the knowledge about this information is required. While we are doing EMF equation problems, turns calculation. Okay. In double layer winding, number of coils is equal to number of slots. Number of coils equal to number of slots. If it is a single layer winding, say, in single layer winding, if it is a single layer winding, see, in single layer winding, number of coils, half of the number of slots. Half of the number of slots. Very, very important conclusions. Remember that. Number of coils is equal to number of slots. I think this you may be knowing in DC machines you might have seen. Not only it is everywhere it is same. I am also going to draw the small diagram that with that you can able to understand. Double layer winding, number of coils is equal to number of slots. Single layer, number of coils is equal to half of the number of slots. Let us see how it is. First of all, what is single layer winding? Double layer winding. Double layer winding means in each slot, two coil sides are placed. Double layer winding means in each slot, two coil sides. That is layers. Coil sides are called two coil sides or layers. Coil side itself called layers. Two coil sides are placed. In each slot, two coil sides are placed. See, this is one slot and this is another slot. Another slot. See, this is another slot. Like there may be so many number of slots. So many number of slots, let it be. Okay. Two layers means, see, this is one layer. This is another layer. This is one layer. This is another layer. Two layers. Two layers, two coil sides. This is one, say this is one dash. One side of the coil is placed on the top layer, other side is placed on the bottom layer for mechanical balance. One top, others one dash. This is two, say two dash. Two coil sides are layers. Two coil sides are layers. Then how many coils are there? Two coils, two slots. So two coils, two slots means number is equal to same. That will be valid for any n number of slots. Is valid for any n number of slots also same. Still to have a good idea, see, double layer winding means how it is. I just want to draw that. This is our stator core. Okay. Right. See, this is one slot and this is another slot. There are so many slots are there now? Yes. Double layer means double layer. This is one layer. For example, black color one layer say. It may have any number of turns. A coil can have, is a multi-turn coil. This is said to be one coil, no? Yes. Black coil. Black coil. And other side, red coil. Also another coil. Another coil. Blue color is one coil, black color coil is another one. Two coils are there. So therefore, these are said to be layers. These are said to be coil sides or layers. Coil sides are called layers. This is called coil sides. Coil sides are layers. They are nothing but are layers. Layers. Therefore, how many coils? I have taken 2 slots. For example, 2 slots are taken. 2 slots, 2 coils. 2 coils. Number is same, na? Number of coils equal to number of slots. Therefore, number of coils, number of slots is valid. It may be any number you take. I have taken only 2 coils, 2 slots. Okay? Yes. 1 dash. So for example, 1 dash is black color, say. 1 dash black color. Red color is 2 dash. 2 dash. Coil sides are layers. Similarly, in single layer winding, only 1 coil side is placed in each slot. In each slot, only 1 coil side is placed. Only 1 coil side is placed. Only 1 coil side is placed. 1 coil side. See here, this is one slot, and this is also another slot. Another slot. Here one coil side, another coil side. That's all. Say for example, 1 coil side, other coil side. Is 1 dash. That is itself 1 coil. Each slot only 1 coil side. Instead of remembering blindly, I am drawing the diagram. This is 1 slot, 1 slot, 1 slot. Okay? This is 1 coil. 1 coil. Yes. Only 1 coil side is placed. Only 1 coil side is placed. This is itself a separate topic, Baba. You require knowledge of this. Because where the students are doing the mistake, turns calculation. Turns calculation. See, what it is required is, earlier I have taken, this is this diagram, 2 slots only I am taking. Two slots means 2 coils I am keeping, 2 coils. 2 coil sides in each slot. We are keeping 2 coil sides in each slot, means it is equivalent to 1 coil, 1 coil. Yes. 2 slots are there, you can accommodate 2 coils. Whereas in single layer winding, number of coils is equal to half of the number of slots. Okay? Meaning is, there are 2 slots are there. How many coils will be there? Only 1 coil you can accommodate. The 2 slots are there means beginning is 1 coil, other side of the coil in the second slot. Now I will ask one question for you. Why I am insisting this much means double layer winding, there is no problem. Number of coils is equal to number of slots. You can remember, number of coils is equal to number of slots, no problem. One is equal to the other one. If you change, also no problem. Left side, right side changes, also no problem, because both are equal. Whereas for single layer winding, what is happening? Number of coils is equal to half of the number of slots. You just interchange. Coils is equal to half of the slots now. Today it is okay. Tomorrow okay. After 1 week, if you open the textbook or this book, again you can find 1 is equal to 1 by 2 other one. 1 is equal to 1 by 2 other one. But which is left side, which is right side is important. Coils is equal to half of the slot. Na? Instead of that, slots is equal to half of the coil, you write, your total answers will be wrong. GATE 2006 examination, one question is given for 6 marks. At that time, double it questions. You need to calculate first of all coils. He has not given coils. Slots are given. You have to calculate coils, then conductors, then substitution. Okay. Now I will put some questions here. In double layer winding, number of coils, number of slots is same. Whereas single layer winding, number of coils are less, number of slots are more. For example, see, 2 slots I have taken. How many coils? Only 1 coil. So number of coils is equal to how much? 1 by 2 into 2. 1 by 2 into 2 slots. That becomes 1. Okay. If it is single layer winding, if it is 100 slots are there, tell me. 100 slots are there. How many coils exist? Tell me. 100 slots are there means you can get 50 coils. 50 coils only. Because each coil required 2 slots, na? Yes. So coils number is less. Okay. Yeah. So with this is fine. Now going back to that, your question, let us see. Now let us see the question. The question is like this. Gamma, since it is double layer winding, number of coils is equal to number of slots. So how many number of coils are given? 48. Number of coils equal to number of slots, that is equal to 48. That is yes, slots is equal to 48. Then calculate gamma. Gamma is equal to P into 180 by S. P into 180 by S. So P is equal to 4 into 180 divided by S. S is equal to 48. This is equal to how much? 4 12, so 15 degrees. Gamma 15. Okay. Gamma 15. Now, what is alpha? Alpha 4 slots are given. Alpha 4 slots. 4 into 15 is equal to how much? 60 degrees. 4 slots are there. 4 into 15, 60 degrees. Alpha 60 means what is Kp? Kp cos alpha by 2. That is cos 60 by 2. Cos 30. Cos 30 is equal to how much? Root 3 by 2. That is 0.866. Your answer is 0.866. 0.866 answer. Okay? 0.866. Okay. Now, I will ask one question, you need to answer. This is over, na? Yes, 0.866. See, dear students, now the question is, in the same question, instead of double layer, if it is a single layer, what is your answer? If it is a single layer, what is your answer? Tell me. Same question, same data, instead of double layer, it is a single layer. What will be your answer? Answer is, tell me. Some of you type it. What is your answer? 0.965, 0.965. Yeah, 0.965. Some of you have given D. D means what? Very good. 0.965 is correct answer. 0.965. Single air winding ante it is going to be, you have to take coils. Okay. In the above question, if it is a single air winding, say, in the above question, if it is a single air winding, just I am writing in the above question. In the above question, if it is a single air winding, if it is a single air winding, then Kp is equal to how much? Kp is equal to how much means number of coils. Number of coils is equal to half of the number of slots. Half of the number of slots. So number of coils are given 48. 1/2 into slots. Number of slots are we do not know. Therefore, what is the slots? Number of slots is equal to 48 into 2. 96 slots you will get. 96. The 96 means gamma how much? P into 180 by S. P into 180 by S. So that is 4 into 180 by 96. How much? That is 7.5 degrees. 7.5 degrees. Then what is alpha? Alpha 4 slots. 4 slots means 4 into 7.5. That is equal to how much? 30 degrees. 30 degrees means what is Kp? Kp is equal to cos alpha by 2. That is cos 30 by 2. Cos alpha by 2. Cos 30 by 2. That is cos how much? 15. Cos 15 is equal to 0.965. That is your answer. Yes. This is the answer. Answer. Yeah. Cos 15. Cos 50. Okay. But at the same time, there is a choice of doing mistake. Choice of doing mistake. Where is the choice of doing mistake? Choice of doing mistake. Where you can, this is correct. Mistake is number of slots is equal to half of number of coils you have taken, say. Number of coils. That what will happen? Half of the number of coils means slots is equal to 1/2 into 48. That is equal to 24, you will get 24. When this is 24 means what is gamma? P into 180 by S. 180 by S. So P is equal to 4 into 180 by 24. That is equal to 30 degrees gamma. When 30 degrees gamma means, then what is alpha? 4 slots. 4 slots means 4 into 30 is equal to 120 degrees. 120. 120 means Kp is equal to cos alpha by 2. Cos 120 by 2. That is equal to cos 60. Cos 60 is equal to 0.5. 0.5. Cos 60 is equal to 0.5. 0.5. 0.5. This option also given. Option also given. Which is wrong. Which is wrong. Correct? Yes. That is not correct. That's not correct, no? No. But whatever this is doing, that is totally wrong. No. 0.5 options also He has given 0.5 also. Some of the students definitely will do 0.5 also, which is totally wrong. Don't do such type of questions. Okay. Yeah. So I have covered all varieties of objective questions. Right? If you find any new questions, you can bring it. Now, then lastly, see, let us see next question. Questions are over. Let us see advantages of short pitch winding. Advantages. Now coming to the advantages of short pitch winding. 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 The advantages, for example, we have taken one. Right? Number 1, 2, 3, 4, 6 slots you have taken. 1, 2, 3, 4, 5, 6 slots. 7, 8, 9, 10, 11, 12 slots we have taken. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 slots we have taken. But 6 slots for North Pole. 6 slots for North Pole. 6 slots for South Pole. South Pole. For full pitch winding means one side of the coil is in the first slot, other side will be kept in the other side of the coil that has kept in the 7th slot. 7th slot. That is full pitch winding. Short pitch winding means we will keep in the 6th slot. We will keep in the 6th slot. Sixth slot. Okay. So advantage is, what is the main advantage? First one. First advantage is fundamental harmonics can be eliminated. Mainly, what is the advantage? Effect of harmonics can be eliminated. Number 1. Of course, I am going to write all the things. First, listen. Effect of harmonics will be eliminated. Already I have shown, na? Yes. If you take alpha 30 degrees, 75% of 5th, 7th eliminated. Primary function is effect of harmonics are eliminated. When harmonics are eliminated, the corresponding iron loss is also eliminated. Iron loss also eliminated. Okay. First advantage is, see here, the advantage is number 1. First one, the effect of harmonics are eliminated. The harmonics are eliminated. Therefore, generated EMF is more sinusoidal. Generated EMF is more sinusoidal. More sinusoidal. Number 1. Secondly, second one, with the elimination of harmonics, iron losses will reduce. With elimination of harmonics, iron losses will reduce. Because hysteresis loss are proportional to frequency, eddy current loss are proportional to frequency square. But once harmonics are eliminated, corresponding iron losses also eliminated. Harmonics losses are more. Harmonic iron loss are more because frequency is n times, no? Yes. Third one is saving of copper at end connection. Saving of copper at end connection. At end connection. Yeah, it is going to be completed quickly, and then if any doubts are there, we will come. Because let us complete the short pitch winding is completed. In the next class, freshly we will start with the distributed. That is my intention. Saving of copper at end connections. Therefore, winding is economical. Winding is economical. Winding is economical. Saving means where you will get saving of copper. Saving, in other words, this much of copper it can be saved here. For full pitch winding, more copper is required. Na? And here also, this much of copper is saved. Saving of copper. This is saving of copper. Not only this side, even saving of copper. Length is less, na? Length is less. Saving of copper at end connection. Winding is not only this side, even this side also. The top side and this side also. On the diagram, you may be feeling very less, but there are thick conductors, na? Even you save that much, a lot of weight of conductors can be saved. Okay. Another advantage is, see, net length of the coil has reduced. Net length for full pitch winding, end connection length is more, na? Yes. But short pitch winding, net length of the coil has reduced. When net length of the coil is reduced, it means self-inductance of the coil is less. When self-inductance of the coil is less, inductive reactance is less drop of voltage. Drop of voltage also less. So, the another one, by adding that advantage, net length of the coil is less. When compared with full pitch, net length of the coil is less. Net length of the coil is less. Therefore, self-inductance of the coil. Self-inductance is proportional to number of turns, na? Number of turns. Number of turns are more, length is more. Simply indirectly you can say self-inductance is less. Therefore, inductive reactance drop is less. Reactance drop is less. Therefore, better the regulation, better the voltage regulation. Better the voltage regulation. Voltage regulation will be better. All these are the advantages. But what is the disadvantage? Disadvantage is small reduction in fundamental voltage. When winding is full pitch, it is arithmetic sum is more. When short pitch, it is vector sum is always less. Vector sum always less than the arithmetic sum. So small reduction at 3 to 4% is reduced. Small reduction in fundamental voltage. Small reduction in fundamental voltage. Fundamental voltage. That is 3 to 4%. 3 to 4% only. 3 to 4% of fundamental is reduced. These are the advantages. Right? Even if you go for, even if you taken, yes. This is short pitch winding. Instead of that, if you do full pitch winding, what is going to be happen? This is full pitch. Long pitch, say, as I told, I was discussing about long pitch. If you do the long pitch also, long pitch like this. It's said to be long pitch. Long pitch coil span is more 1 to 8. 1 to 8 ante long pitch. Its angle is more. But long pitch also you will get the same advantage. Disadvantage is more copper is required. More copper is required. More copper. Even this is E1. What is this? This is E6. This is E7. This is E8. E8. But all they are equal. E7 is equal to E8. E6 also equal to E8. E1 is also equal to E7. All they are equal. If you draw for full pitch winding, this is E1. This is E1. See, E1 is equal to E. This is E7. E7. This is E6. E6. What is this? This is E7. E7 is also equal to E. E6 also equal to E. This is alpha, short pitched by alpha. If it is over pitched by alpha, say over pitched by alpha. Over pitched by alpha. E1 to E6, what is the value? E1 to E6. If you take it, this resultant is equal to how much its resultant? ER. That ER is equal to 2E cos alpha by 2. 2E cos alpha by 2. Even for this is also it is same. Even if you take E7 also. E7. This resultant also same. ER. That also same. What I mean to say is, if short pitched by one slot, over pitched by one slot, pitch factor same. Pitch factor. Vector sum same, na? Short pitched also, over pitched also, vector sum same. Arithmetic sum is anyhow 10 plus 10, 20 volts. Therefore, short pitch factor is equal to long pitch factor A. Short pitch factor is equal to long pitch factor, both are same. Short pitch factor is equal to short pitch factor is equal to long pitch factor. Both are is equal to cos alpha by 2 only. Cos alpha by 2. Same. Whether you do long pitch or short pitch, 30 degrees short pitch, 30 degrees over pitch. KP same. Harmonic elimination also same. Harmonic elimination also same. All advantage with over pitch same as. All advantage with long pitch. Long pitch is the same. Same as short pitch. Short pitch. But more copper at end connection. More copper at end connection. End connection. That is a disadvantage. More copper is required at end connection. More copper at end connection. More copper. More copper is required at end connection. That's the reason practically machines are never be. Therefore, machines are never be long pitch. Never be long pitch. You never go for long pitch, short pitch or full pitch. Okay. Yeah. With long pitch also, harmonics elimination, same. I will give one question. Tell me answer for this. The question is, last question. The last question. One of the examination question. In which of the following winding harmonic content is more? Harmonic content is more. Harmonic content is more. Number 1, short pitch, A bit. A bit short pitch, B bit. Long pitch, C bit. Full pitch, D bit. Equal for all. Equal for all. Which of the following winding harmonic content is more? A bit short pitch, B bit long pitch, C bit full pitch, D bit equal for all. What is your answer? Which winding is more? Right? What is the answer? Answer is harmonic content is more in full pitch only harmonic content is more. Long pitch also harmonics are less. Harmonics content is less. Okay, fine. So with this, short pitch winding is completed. Short pitch winding is completed. Now, if any doubts are there, let us discuss. Yeah. Shirisha, I am unmuting. Vishnu Ajit.
Yes, sir.
Yeah, tell me.
Sir, my doubt is regarding the first part, sir. This pole pitch, you drew that graph, no, sir. That North Pole and South Pole 180 degree sinusoid.
Yes.
Sir, could you explain how that came? Like, my understanding is how it came, sir. I mean, I'm not able to read.
Pole pitch means angle for each pole.
Yes, sir.
Angle for each pole means, I think this was okay. See, this is 4 poles are there. Okay, when 4 poles are there, how many pole pitches? What is the meaning of pole pitch first of all?
Angle between 2 poles.
Angle between 2 poles also. How much angle it will be? North, south, north, south. You take angle between 2 poles. This is one, this is one. This is, you can also call pole pitch, correct only. How much angle? This is 180, I can say.
Yes, sir.
Electrical angle, peak to peak, no? If you want to draw peak to peak, say this peak to this peak, that is the angle. What is this angle? Is
180.
180 or not? Yes.
Sir, my doubt is actually why it is sinusoid, sir. The distribution why it is because we need EMF as sinusoid. That's why.
Distributed?
I mean to ask why is this? Why is this in sinusoid nature? That is North Pole we represent as positive peak and South we represent as negative peak.
Each pole will, what is the flux density? North pole, B wave say. North pole is giving positive half cycle, South pole is giving negative half cycle. Flux density only. By chamfering salient pole, how you will get? Okay. And in turn, they will generate the sinusoidal EMF. North pole will generate positive half cycle, south pole negative. The cross dot. If you are interested, I can say north pole negative cyclicity. Okay, you can take it.
That's depending upon our reference only, no, sir.
That's yes, reference only.
And sir, one more thing is the slot pitch, sir. The slot pitch, the formula that we use is 180 divided by slots per pole.
Yes.
So is it equal to 360 divided by number of slots? That also will give us the same answer.
360 by
number of slots.
No. If it 360 degrees means this mechanical angle it becomes now. Gamma will get in terms of mechanical degrees. No. You want electrical angle. Electrical angle means this is mechanical, you are correct. But electrical is equal to 360 degrees means is equal to P into 180. P poles are there, say.
Yes, sir.
360 degrees mechanical. If I keep 4 poles means 180 is how much total? 720.
Yes, sir.
725 slots. If I use some 8 poles, 8 into 180 it becomes 8 into 180 by 12. Not 360. Okay. Whatever you are saying, it is mechanical.
Yes, sir. Mechanical.
Not mechanical. Mechanical you are correct, but every time we need to take electrical only.
So this entire discussion is relevant only in terms of electrical angle.
Yes. Anything is not mentioned, nothing is mentioned, you have to assume every time electrical angle.
Okay, sir.
Okay, right. Okay, next.
Thank you, sir.
Right. Sirisha. Yeah. I'm unmuting all the people. Please, you can ask.
Hello, good evening, sir.
Good evening.
Good evening, sir.
Yeah,
sir, in the induction generator principle, where generator or motor, we are saying that is NR will be either slow or either move faster than NS.
Yes.
Then here in synchronous there is magnetic locking condition is there.
Synchronous machine?
In synchronous there is magnetic locking is preferred.
Yes. Magnetic locking exists. Yeah.
Means what is the main difference? Means if NR will be slower than NS in induction motor, then there will be torque production. Why this is called?
Your doubt is you need to compare synchronous motor and induction motor.
Yes.
The induction motor rotor always rotated synchronous speed. Synchronous motor rotate only synchronous speed. See, yes. In induction motor, if rotor rotate, what is the poles? Rotor poles, tell me.
Rotor poles.
No poles.
The rotor poles is rotating, na? Sorry, that is at NS speed.
No, you forget about that. First of all, if rotor rotated synchronous speed, will be there any poles are formed? This is your stator core.
Yes.
Okay. The stator poles are rotating at synchronous speed, 1500 RPM, say.
Yes.
If your rotor also rotating at 1500 RPM, same speed, will the rotor conductors will be there any induced EMF? Slip is equal to 0, na?
Yes.
Now there is no induced EMF in the rotor conductors. No induced EMF means no poles will form, rotor poles. If there is no rotor poles, no torque will be developed. No torque will be developed.
But rotating RMF of starter and rotating RMF of rotor will be equal.
Yeah, that is okay.
For constant torque production.
That both will be stationary. When rotor rotate 1400 and pole will rotate on the periphery at slip speed. 1400 means plus another 100. So 2 will be stationary.
Yes.
2 will be stationary.
Yes.
But in our synchronous motor, see, synchronous motor, what will happen? This is north pole. In synchronous motor, is there any induced poles? No. Separately excited. If
okay.
I am giving this is north pole. Okay. This is south pole, say. By excitation, we are getting some south pole, south or north, forget about. I am not. Or else if you take this is 1 minute. This is what I am going to discuss at synchronous motor. I will compare synchronous motor generator. So this is south pole, this is north pole, no? North pole.
Not.
This is south to north. This is rotating 1500.
Not.
1500. My rotor also will rotate 1500. When rotor
Yes.
rotated 1500 due to magnetic locking, synchronous when rotor rotated synchronous speed, will these poles will disappear or the poles exist?
Poles are exist, sir.
Why? Correct.
Okay, means
Why? Because separately exciting.
separate.
And when relative motion will be when both are stationary, when rotor rotated synchronous speed, then only two fields are stationary.
Yes.
Is there any RMF on the rotor? Synchronous speed? Will be there any RMF?
No, because we are self-excited.
DC excitation you have given. DC. If
DC.
rotor rotate, then only pole will rotate. That's all. But induction motor on the rotor, RMF is again produced. Slip speed it will rotate.
Yes. Okay.
But here, rotor is itself at what speed rotor rotate, rotor pole rotate. If rotor is 0 speed, say rotor poles also 0 speed. Rotor 1400 RPM means then rotor poles also 1400. Rotor is itself pole here. DC excitation we are giving. It's not just like that. A rotating magnetic field is not produced on the rotor because induction motor currents are AC.
Yes.
When rotor rotated synchronous speed, then only two poles are stationary, then only torque will be developed. This production of the torque we are going to see before armature reaction. After 2-3 class, I am going to rotating magnetic field, torque production. Again, we are going to see. Okay. Meanwhile, I will compare at the time of synchronous motor, induction motor, synchronous motor.
Sir, in the previous class, you have written a term that B will be in form of theta and EMF will be in form of omega t.
Yes. Because that is B will be in the space. Theta is space angle. In space, flux distribution in the air gap, it is getting like that, na? Yes. But of course, induced EMF is time angle. Induced EMF is time. Why? Because the harmonics, space harmonics will give rise to time harmonics in the generated EMF. Induced EMF you can write always in terms of omega t.
Okay.
That is with respect to space flux distribution. It's not with respect to time.
And sir, in a B average calculation, because it is specially distributed.
Sorry?
The B wave will be in a DC machine that we are getting that B will be B average.
Yeah. B average is equal to 2dl by P into B max. That relation we are going to get.
But here we are getting, because of rotation, this will be sinusoidal.
Which one?
In synchronous.
Space, this is because of why we are getting, not by rotation, by chamfering the salient pole we are getting.
Okay.
Space means what? Here it is air gap is less.
Space means that is in the
under
air
one
gap.
pole pitch, if you take under one pole pitch in space, gap is less, na? Due to this,
Yes.
flux distribution is more here, less here. This is space. Space means air gap periphery. Air gap
Okay.
periphery. Wherever rotor may be there, you will get sine wave only. For example, under one pole, you will get sine wave.
Yes.
Why? Because we have done chamfering.
Choppering. Yes.
Even while rotating also, under every pole that will be sine wave. It will generate the EMF waveform. But
Means
when
one. Means if one observer will be moving around the whole cycle, means mechanical angle, this will be also sinusoidal.
But what is your doubt? This is flux distribution, fine. How it is there? While rotating only it is cutting the flux, okay. Under north pole it is sinusoidal flux distribution. Sinusoidal flux distribution means it is, don't think it is not AC, DC only. I want the flux distribution to be sine wave, means when conductor is there under the pole, it will cut the maximum flux density. When portion of the pole is
Yes.
moving, say it won't cut maximum value. For example, pole is exactly under this. If pole is rotated some 10 degrees, say, will it cut maximum flux? No. It is going to be reduced. And the shape of the voltage waveform is same as shape of the B waveform, flux density waveform. Flux density.
Yes, sir.
Not flux waveform. Flux waveform we are not trying.
Flux is directly DC excitation during.
Flux is
Yeah,
not a
after
flux.
rotating, we are finding.
Yes,
Okay.
yes. Okay. Right.
Thank you, sir.
Right. Next. Hello. Hello. I'm unmuting all the people. Who is there? Yeah.
In case you have told that,
Hello. Tell me.
hello,
Yeah.
sir, in one case you have told that pole pitch is equals to S by P, no, sir. How we can say like,
You take any example. See, a three-phase. Okay, two pole, 12 slots. Say same example.
okay,
Okay.
sir.
What is gamma? P into 180 by S. Na? P is equal to 2 into 180 divided by 12. What is
Yes,
this angle? 30. No?
yes, sir, slotting.
See. Pole pitch is equal to, what is this? Pole pitch
180.
angle. Pole pitch is equal to how much?
180 degrees.
180 degrees. Correct?
Yes, sir.
Pole pitch is equal to, I can also write slots per pole. Slots per pole. How many slots are there?
There are 12,
12 by 2.
12 by 2. Yes, sir.
Is equal to how much?
6, sir.
6 slots. 6 slots is equal to how much angle again you calculate?
180 degrees, sir, again.
That's what. Slots are given, you need to convert that into angles. You can represent coil span in terms of slots per pole. Slots also, coil span is equal to 10 slots means how much? 10 into its slot angle.
Okay, sir.
You take any data, pole pitch is equal to 180, slots per pole is also equal to 180 degrees. But slots you are getting, don't think 6 slots means you need to convert that into angle. 6 into 30, 180.
Okay, sir.
Any data you take, it will be valid. You just to choose your own problem, you can verify this will be valid.
Yes, sir. Understood. Thank you, sir.
Right. Next, hello. Yeah. Who is there? I'm unmuting all the people. Please ask.
Hello, sir.
Hello.
Hello, can you hear me, sir?
Yes.
Sir, my doubt is in theta electrical. Means how to understand it physically. What is its physical significance?
See, ma, one conductor, you take one conductor. Okay,
Yes,
4
sir.
poles are there. Within one rotation, how many half cycles generate in this conductor? 4 half cycles. North pole is going to generate positive half cycle. South pole is going negative half cycle. Again, north pole is positive. South pole. 4 half cycles you will get within one rotation. Okay.
Yes, sir.
For mechanical angle of mechanical rotation 360 degrees. But in this, how many half cycles you are getting? 4 half cycles.
4.
What is the angle it is contributing? 4 into 180, 720 degrees.
Okay, sir.
Electrical angle mante each pole angle is equal to how much? Each pole electrical angle. Each pole generate one half cycle. Na? One half cycle means it is 180 degrees you need to take. Or
Okay,
else,
sir. It is there. Means everywhere in electrical, it is there. Like we measure electrical angles in electrical angles only.
yes, electrical angle only.
Okay, sir. In double layer winding, what does it mean when you said that number of coils is equal to number of slots? Like if there are 3 slots, then will that the coil or the windings will be placed in 3 coils, three slots?
Yes.
How would be the turns then, sir? Like इसमें एक
Three
round
won't
लेके वो
exist,
वापस
na?
आ जाता है.
No, 3 slots won't exist. Ma. You have to take even number always slots. Otherwise, how you can keep coil sides?
Okay, sir. I
Coil,
got it,
you
sir.
cannot have 1.5 coil cannot exist. Na? Theoretically, okay, but practically, how your doubt I understood. 3 slots, how can you keep all 1.5 slots? You cannot keep, no, 1.5 kind. 4 you take better. 4 you take. Even number you take. Okay?
Okay, sir. Yes, sir. Thank you, sir.
Welcome. Next, hello. Yes. Who is there? You can unmute, please. I am unmuting all the students. Yes. Shirisha. Shirisha, are you there? Ganga. Secha. Okay. Yeah, I hope. So today it's over. I will close session.